And we are recording. Good morning, everyone. Welcome. Thank you for joining us on this early Monday morning. My name's Ebony Roan. I'm your OPSERT program coordinator in the Safe Drinking Water section. And today we have a whole group from ADEQ ready to go over PFAS for you today and PFOA regulations and treatment, including funding at the end. Just a few housekeeping rules for all of our guests in attendance today. You are receiving professional development hours today by attending the entire session or even part of it. Up to today from 8 to 12, you can receive up to 4 PDHs. The agenda, including the PowerPoints you'll be seeing today, are located in the handout section, as you see in the picture to the right. If you are unable to get the agenda or the handouts for any reason, please email us. Our email is below at azopsert at azdeq.gov, or you can give us a call at 602-771-0100. Just so you know, all your webcams are disabled and you are muted. So if you have any questions or comments, please use the question drop-down box to the right, which should be below the handout section. Okay. For the agenda today, we're going to start with proposed PFAS National Primary Drinking Water Regulations. We're going to move on to the PFAS sampling projects ADEQ has been hosting for the last year, into PFAS treatment. If you were here for our last PFAS webinar, some of this might look familiar, but it's still some new information for others. We have ADEQ and WIFA funding coming up at the end. There is going to be a break after PFAS treatment. Apologies for not putting that in there. And then at the end, we'll have an additional few minutes for any questions we didn't get to. With that being said, we're going to go ahead and send this one off to Karen. Karen, are you ready?
Yes, yes, I am.
Perfect. You have screen control, and let me know when you're ready for the video.
Okay. Can you see my presentation, Ebony?
We're seeing your notes and your presentation.
Okay, just a second.
Worries. Perfect. Just your presentation's visible.
Perfect. And good morning, everyone. I'm delighted to see so many participants this morning. We do have a great agenda, as Ebony mentioned just a few moments ago. I'll be starting us off with proposed PFAS regulations. Again, my name is Karen Shanafelt. I work here at ADEQ in the drinking water section. I'm a unit manager, specifically over our inspections, compliance, and enforcement unit, and also over source water protection. Before we get started, I would like to show a video that ADEQ has developed. It's an introduction to PFAS in Arizona. It's about a 12-minute video, and I realize that many of you on the call today are probably fairly well versed in PFAS, have been hearing about it for several years. But this video was a great introduction, and as public water systems become aware of PFAS in their water, it's imperative that your communication to your customers and your residents is clear and in an understandable format. And so after watching this video, I would invite you to include this link on any public notices that you're issuing out to your residents. Even in your consumer confidence report, I think people today are more inclined to watch a video rather than reading a multi-page report. So with that, I'd like Ebony to link the video if you could.
Definitely. I'll go ahead and start it up. Apologies real quick though, Karen. Do you mind if we launch the poll before the video?
Oh, sure. I'm sorry. I totally.
No, that was me on a Monday morning. Let's see. Before this video, it's quite nice. We're going to go ahead and launch this quick poll. The last two questions are just going to be a pre-webinar knowledge question, but they will be answered at the end. So if you can go ahead while we have people still coming in. Have you sampled for PFAS at a public water system prior to this webinar? We just want to gauge everyone's understanding of PFAS, their initiatives, if they're just here to learn, if they're just here to refresh. Okay. A good amount there. We'll wait till we get to about 65%. All right, good. Wow. So just off the trend alone, it looks like we're kind of breaking even. I'll go ahead and close this. Go ahead and share those results. We're breaking a bit even here. Yes and no. Currently learning. Thank you all for attending. All right, do one more. How familiar are you with the following PFAS treatment technologies? These are just a few in a long list. If you know of others, please go ahead and mention the last button. And this is a multiple choice as well. Okay, give this another 10 seconds. And that is okay if none of this sounds familiar to you. All right. And we'll share this one. It looks like a lot more for the GAC and the anion exchange resin than PAC and then other treatment methods, which there are plenty of. We'll definitely be covering a few of those later on. Okay. This is a very quick question. If you are certified, we would like to know what's your highest grade of certification, even if it's a 4 in wastewater and a 1 in water treatment. If you are certified. Those of you who are not certified, we do have operators in attendance for these webinars, so we do like to know who our audience is. Go ahead and close this one in 5 seconds. It looks good. Currently, we have quite a few 3s and 4s, welcome, and quite a few grade 1s. That's really good to see and really good to hear. Because yes, all of the sampling will involve you. And then for our last questions, our last 2 questions, like I said, they're just pre-webinar questions. Currently, if you're on the up and up, just take your best estimate. What is the PFOA proposed NCL? Okay, perfect. We'll have 2 more seconds to take your best guess. All right. Looks like we got 71% for the 4 parts per million. Oh, 4 parts per trillion. There we go. A2. Perfect. Last question. What is the EPA proposing to oh my gosh, that word. Hey, Karen, help me out. It's so early. Promulgate.
Promulgate.
Can you explain that word to us, please?
When they're finalizing the rule.
Thank you. Originally, this is going to end 2024, but has been postponed. That's just our abbreviation, 2023 or 2025. All right, perfect. Closing this, and we're going to share those results. Looks like we're looking for conclusion to the standard in 2024, some in 2023, some believe 2025. All right, we'll cover these last 2 questions towards the end of the webinar, but thank you for your participation. I'll go ahead and start that video. Let's see, here we go. Oh, I said.
Okay. Hopefully everyone enjoyed the video, and like I said, it's a very great foundational video that helps explain PFAS. And hopefully it's something that you can, like I said, link to any of your communications to your customers and your residents to help them understand some of the risks involved with PFAS in your water. Ebony, can you see my screen still, my PowerPoint?
Looking good.
Okay, perfect. So with that, I'll go into the PFAS regulations as they pertain to drinking water, and it is referred to as the PFAS Proposed National Primary Drinking Water Regulations. And I'll use the abbreviation NPDWR. What makes the NPDWRs different than any of the health advisories or interim health advisories that we've seen in the past is that these will be enforceable standards, such as maximum contaminant levels, which would apply to public water systems. As many of you are aware, we have over 90 regulated contaminants. Many of them have maximum contaminant levels, some have treatment techniques, some of them have action level exceedances, but they are enforceable, as I mentioned. EPA must promulgate an NPDWR if there's an emerging contaminant that has shown to have adverse health effects. If that contaminant or contaminants, they occur substantially at levels of concern, and if regulating those contaminants is an opportunity to reduce any kind of health issues. And so as EPA has worked their way through this process, they have indeed demonstrated adverse health effects. We've seen, unfortunately, the prevalence of PFAS throughout the country at varying levels, and clearly there would be a true health risk reduction if regulated. My footnote there is that EPA is proposing that the PFAS NPDWR will not apply to transient systems. And again, as a reminder, a transient non-community system is one where you're not serving water throughout the year. It may be a restaurant, a hotel, a campground, where people are drinking the water maybe once or twice a year. When EPA develops a standard or an MCL for a new contaminant, there is an actual process that they need to follow. First, they need to evaluate the data, the available data. And so there has been quite a bit of toxicological data around PFOA and PFAS and some additional PFAS chemicals as well. They are reviewing the best available peer-reviewed science studies. That process is ongoing as we become aware of more toxicological data for additional PFAS. They have tried to categorize PFAS because, as mentioned in the video, there are thousands of different isomers and different chemicals classified under the PFAS name. Once they review the toxicological data, they need to establish what we call the MCLG, or the maximum contaminant level goal. And this is where a level where there's no known adverse health effects, which would allow for an adequate margin of safety. And I'll talk about the MCLG in just a moment, but this helps gauge where this particular chemical or compound should be regulated. After establishing the MCLG, they develop a rule analysis where they're looking to see if a true health risk reduction would take place, if there are any kind of policy alternatives that might apply. Then the fourth step there is to set the standard as close as feasible to the maximum contaminant level goal. And in March of this year, EPA did release the proposed MCL levels, which we'll talk about in just a moment. And they've taken many items into account, including best available technologies and cost, in order to come up with the maximum contaminant level. And last, but certainly not least, there is a benefit cost determination. So they do look at the cost of treating PFAS down to the maximum contaminant level. At what point does it become cost prohibitive and things of that nature. So cost is definitely a major factor in developing the rule. This slide identifies that EPA does not create rules or regulations in a vacuum. They gather and have been gathering input from several different stakeholder groups and have held public meetings. Once the proposed MCL was released, they took comments from local, state, and tribal governments, from public water systems directly. The Small Business Advocacy Review Panel provided guidance as well, Science Advisory Board, National Drinking Water Advisory Council, and public meetings throughout the country to address some of the environmental justice considerations. So definitely a lot of stakeholder input goes into this process. As touched upon in the video, there are definitely health effects attributed to PFAS, and EPA has reviewed all of the scientific data, and it has been determined that the two most primary PFAS compounds, PFOA and PFAS, are likely to be considered carcinogenic to humans, and therefore the maximum contaminant level goals are 0. So there is really no adequate margin of safety. So the MCLG is 0. And in the graphic here below, it does identify some of the health effects that have been attributed to PFAS, such as thyroid disease, high cholesterol, potentially breast cancer, reduced response to vaccinations. That's been obviously a highly charged issue with COVID and things of that nature. Liver damage, kidney cancer, pregnancy-induced high blood pressure, decreased infant and fetal growth, ulcerated colitis, and testicular cancer, just to name a few. What is so monumental about this drinking water standard is that EPA has not added any new contaminants to the Safe Drinking Water Act since 1996. And so this is a historic moment for the Safe Drinking Water Act in that we haven't, like I said, seen any new contaminants. But the other item to make this so unique is that these proposed levels are so low. There are only a handful of other contaminants that are regulated down to these levels, and I believe dioxin and I want to say some of the PCBs are only regulated anywhere near the part per trillion level. Typically, we will see maximum contaminant levels in the part per million or part per billion. But as I mentioned, for PFOA and PFAS, the maximum contaminant level goals are 0, and the proposed MCL levels, which as I mentioned, once that rule is finalized, they will be enforceable. Right now, it's proposed at 4 part per trillion for each. So they are not regulated as a combination, as we've seen in the past with the health advisory levels. They are separated out. What's a little bit confusing is that there are 4 additional PFAS compounds that are regulated as a mixture, and it's referred to as the health index. And again, it's a unitless hazard index, and I'll go over it in a little bit more detail. But it does account for the fact that the more PFAS that you're exposed to, there is a dose additivity whereby your health, the adverse health effects are increased with more exposure to different PFAS groups. The health index helps to evaluate the potential health index from exposure to chemical mixtures based, again, like I said, on the assumption of dose additivity. These are not MCLs, nor are they MCLGs, but rather they are the health-based water concentrations, or HBWCs. So for PFHXS, it is 9 part per trillion. For PFNA, it's 10. For PFBS, it's 2,000. And for HFPODA, or what most people refer to as Gen X, it's 10 part per trillion. And this chart is taken right off the EPA guidance. This slide does look a little bit, complicated, and there is a little bit of math involved in helping to to calculate the health index, but I'll try to break it down for you. It's really just developing or creating a fraction so you understand what piece of the pie each of those 4 PFAS compounds contributes to the whole. And so if you take a look at Gen X, like I said, that health-based water concentration is 10, and you would then take your Gen X amount that when you've analyzed your water, and you place that on in the numerator on the top over the 10. You do the same for PFBS over 2000, PFNA over 10, and PFHXS over 9. And for public water systems, AGQ would absolutely help to calculate these health indices for you. And so there's no need to be concerned about it. We're always there to provide assistance and guidance, but it is good to understand the math behind it. And again, we're looking at a health index value of anything over 1. So if you find that the fractions all add up to greater than 1, that's when you've exceeded the health index. If these pieces of the pie, as I mentioned, are less than the whole pie or less than 1, then it is below the regulatory standard of 1. Here are a couple of examples, and again, I've taken this straight from EPA to give you an indication of how this plays out. So for instance, if you look at example 1, and we've developed the different fractions here based on the 4 compounds, you can see that in this first example, each of those each of the chemicals is below except for PFHXS. This one is right there on its health-based water concentration. But collectively, this adds up to 2.1. So that would exceed the health index MCL or health index level, even though, like I said, the 3 of them are below the level. The second example is showing you that each of these individual PFAS compounds is below its own health-based water concentration, but again, collectively makes up a greater than 1. Once you add the fractions, it's greater than 1. It's a 1.1. So again, you would be exceeding, even though individually none of the 4 is exceeding. The third example is to demonstrate that you could have 3 of these chemicals be at 0, but if you're slightly above your health-based water concentration here of 12, then again, you would be exceeding slightly over that 1 at a 1.2. And then finally, example 4 shows that if you're below each of the health-based water concentrations, and if you're well below, collectively, you could still possibly be below the 1 health index. So that last example is the only one that is not exceeding. And just as a comment, and Matthew hopefully will correct me if I'm wrong, I think to date we have not actually seen any Gen X within the state of Arizona, or we're not aware of any at the current moment. Sampling is obviously still continuing, but we've been lucky enough as a state not to see any Gen X.
You're absolutely correct on that, Karen.
Oh, okay, perfect. Glad to hear that. So what does EPA expect public water systems to do once the rule is finalized? And this should not come as a surprise to anyone, because this is what all public water systems are currently doing with the national primary drinking water contaminants. EPA would expect public water systems to monitor for the PFAS compounds, and I'll go over the monitoring schedules in just a moment. If a water system is exceeding, there is a requirement to public notice for your levels of PFAS, and I'll go over how quickly you would need to public notice for your PFAS exceedance. And then lastly, and this is the big one, if you are exceeding for either the PFOA or the PFAS, or like I just talked about, that the health index with the 4 additional compounds, you would need to reduce those levels of PFAS in your drinking water. And I know Yasmina will go into different treatment techniques, but either through treatment or consolidation, you will need to bring those levels down. EPA does anticipate that once the rule is fully implemented, that this rule will prevent tens of thousands of serious PFAS attributable illnesses or deaths. So regulation of PFAS compounds, some would argue, is long overdue, and we're finally on the precipice of the final rule being implemented. This is where it gets a little complicated as well. I'll try to break this down. Once the rule is promulgated, and we anticipate that the rule was to be promulgated by the end of 2023, so December of 2023. Obviously, that's about a month away. EPA has indicated that that's likely going to be postponed by a couple of months. Hopefully in the spring of 2024, the rule will be promulgated. From that point forward, it will allow states to implement that rule within 3 years. So if we stick to the original date of December 2023, like I said, states will have to implement by December of 2026. If it gets postponed to spring of 2024, then that would obviously be spring of 2027. The EPA is proposing that the initial monitoring requirement is as such as broken down on this slide. If you are a large system serving over 10,000 people, or you're a surface water system, you will have to provide 4 quarterly samples within a 12-month period. And so that's for large systems. If you're a small system, and the majority of our public water systems in Arizona are well below the 10,000 population level, you will have to sample twice within a 12-month period. Now, the paragraph at the top indicates that your initial monitoring has to take place once the rule is promulgated, between promulgation and implementation. However, EPA has also considered, and this is the last paragraph on this slide, that public water systems may be able to use recent or previously acquired PFAS drinking water data, either from UCMR 5, which is the unregulated contaminant monitoring rule, which is obviously currently in process through 2025, or state level drinking water occurrence monitoring data, which Matthew will talk about in detail, or other appropriately collected PFAS data, which needs to meet all the quality assurance and all the quality assurance items that normally apply for UCMR. So this is a huge aspect, because for those of you that have done any PFAS sampling, it is quite costly when you compare it to other contaminants in the Safe Drinking Water Act. And we are trying to assist those small systems as best as possible to get to monitoring data points so that these systems can use this as their initial monitoring. So once the initial monitoring period is over, what will the ongoing compliance monitoring include? So quarterly monitoring will be the normal frequency for all sampling locations. You should be able to apply for reduced monitoring down to once or twice every 3 years if you fall below the trigger. Currently, the trigger is 1/3 of the MCL. So I'll break this down a little bit more in the next slide. And then a system that's in violation, if monitoring, your system's in violation if you exceed one of the MCLs. So again, if you're a system and you trigger, which the 1/3 proposed MCL trigger is, again, very low. Typically, we will see a 1/2 MCL trigger like we see for nitrates and things of that nature. And a trigger is a level that would require that system to increase their monitoring and keep a closer eye on that contaminant. So 1/3 is, again, very low. For PFOA, it's 1.3 part per trillion. For PFAS, it's also 1.3 part per trillion. For the health index, we're down to 0.33. And again, that was that that pie where the 4 contaminants make up that whole. EPA did request comment on this trigger during the summer, and they are considering the alternate trigger level of 1/2. But again, none of this has been finalized, but this is really a key component of this rule. This could be very difficult to implement for the fact that, to the best of my knowledge, these levels are the lab is not able to get to detect down to these levels consistently. So this is really, we're hoping that that trigger level increases to 1/2. As I mentioned earlier, if you indeed have PFAS at levels above the MCL or above the health index, you will need to public notice. EPA is proposing that the PFAS National Primary Drinking Water Regulation would be a Tier 2 notification. So just to remind everyone on the call, a Tier 1 notification means you have to notify your system within 24 hours, and that's for acute contaminant like total coliform hits or E. coli or nitrate. A Tier 2 notification means you have to let your customers know within 30 days. A Tier 3 is more or less for violations that fall into paperwork and monitoring, and that is a 365-day notification. So for PFAS, they were proposing a Tier 2 notification. If you do exceed for PFAS, EPA is proposing that the community water systems would be required to include that information in their consumer confidence report. And again, as I mentioned earlier, including the link of the PFAS video that we showed at the beginning would be a great tool that you can use to help communicate. You will have to indicate the level of the regulated PFAS that was measured in your drinking water. You have to identify the health effects of that PFAS compound that was detected as well. So again, in line with other contaminants that are regulated as a national primary drinking water standard. Yasmina will go into this in greater detail, but EPA did evaluate the technologies that demonstrate effective removal of PFAS, and they've identified granular activated carbon, anion exchange, nanofiltration, and reverse osmosis. And there are definitely pros and cons to these different treatment technologies, and it really depends specifically on your water chemistry and what PFAS you're finding in your water. So as you eventually, some systems will need to move forward with treatment, you really need to make sure that you're considering the appropriate treatment technology. EPA does anticipate that with these proposed MCLs, that 66,000 water systems are subject to the rule, which means, again, this includes community water systems and non-transient, non-community water systems, but excludes or does not include transient non-community water systems. And they estimate that approximately 5 to 10% of those systems will exceed for one or more of the MCL limits. And how does that apply to Arizona? So in Arizona, the rule will apply to 946 water systems. And currently, with our current data, we are aware of 71 public water systems that, if the rule were finalized today, would be exceeding the MCL. So we're right in line, unfortunately, with the anticipated exceedance at the 7.5% of those systems. And again, community water systems, non-transient, non-community water systems. And with that, I'm happy to field any questions you may have.
Thank you very much, Karen. Excellent. We have a few questions here in the chat. What does ADEQ stand on regulating PFAS until EPA finalizes the rule? And how about PFAS and wastewater treatment plants, liquid and biosolids or sludge? And what do you suggest that the wastewater treatment plants do should be doing beforehand?
This is a great question. where the state stands. So Arizona has not promulgated their own PFAS standards. Other states that have much higher levels of PFAS have regulated their own standards. When it comes to safe drinking water, Arizona aligns itself with the federal rules, and so we will wait for the finalization of the drinking water national primary drinking water standard and align ourselves with that. For wastewater systems, I know once we've kind of moved forward with the drinking water standard, there will be a greater focus on wastewater. If you're a wastewater treatment facility, I do suggest sampling, getting an idea of what your PFAS levels are, just to have an understanding of where you stand. One thing that I would like to reiterate, that if you remember one thing from my presentation and nothing else, is that even though it will take 3 years for the rule to be fully implemented, as a public water system, do not wait. Because if you're a system and you're exceeding and you know you have PFAS in your water, it can legitimately take 2 to 3 years by the time you secure funding, go out to bid, do a pilot study, construction. So you need to act now. And the other thing I want to reiterate is that funding is available now. Once we change, or if there's a potential change in administration in 2024, things may change. So my one suggestion is to a public water system, do not wait. If you know, you need to apply for funding sooner rather than later. And I know we'll be touching upon funding later in this webinar. Hopefully I answered the questions.
Thank you, Karen. If there are any follow-up questions or further questions, please post them in the questions box. Karen, I do have one more for you here.
Okay.
Will the Monitor Assistance Program sample these PFAS? If so, will MAP fees be increased to cover the cost for these new samples? Any estimates what a set of semi-annual sampling plans might cost? And we can break this up into 2 questions if you want.
I know that we are trying to prepare ourselves so that PFAS could potentially be included in the MAP program, and I don't want to misspeak on this because none of that's been finalized, but MAP has typically been able to sample for any contaminants at the EPDS, or the entry point to the distribution system, which is the point of compliance for PFAS. And I believe MAP fees, I want to say, will increase, unfortunately, if they haven't already, to try to account for this increase in sampling. Sampling for PFAS is quite costly. So yeah, we are hoping to be able to exercise our ability to get some of those fees down for some of these smaller water systems.
Okay. Thank you. And then to continue on the same person's question, is the 3 million Safe Drinking Water funds paying for the initial samplings for the small public water systems?
Yes, the 3 million is paying for the initial sampling that we're hoping can apply for that initial monitoring period. Yes, it definitely is. And
Okay.
that data can be seen on our website. We have a PFAS resource map that was indicated in the video originally.
Perfect. I think that concludes all the questions for now. If anyone does have any more questions for Karen, go ahead and post them in that questions drop-down box. If you have any that you can't post yourself because of the platform you're watching, go ahead and feel free to email the OpsWork program. We'll send those questions over to Karen. So in the meantime, thank you very much, Karen, for your time.
No problem. Thank you.
Perfect. Moving ahead a couple more minutes ahead here, but that is okay. Matthew,
I'm here.
you're on board? Perfect. Excuse me, showing the wrong screen there. I'll go ahead and give you viewing power if you're ready to go right now.
Sure.
Perfect.
Okay. Can everybody see my screen?
Looking good.
Perfect. Okay. Well, first off, great job, Karen. Awesome. Hard to follow, but um, thank you so much for letting me present today. My name is Matthew Olson, and I'm also in the drinking water section, and I am a PFAS project manager here at ADEQ. I've been here now just over a year, so very exciting to be working and focused really on PFAS since I've been here. And today, some of the things that I want to talk about are what are PFAS, the history of PFAS sampling, findings in Arizona. I want to then go into really mostly in detail with the 2023 ADEQ PFAS sampling project that we've been focused on. Then we can touch a little bit about support and moving forward. And if anybody has some questions at the end, we can absolutely try to address those. So this is a great slide I always like to start off with. People are always asking, well, where are PFAS chemicals, right? They've been around since about the 1940s. There's a lot of PFAS, unfortunately, in quite a few consumer products and industrial applications. People think about, wow, they're just the non-stick coating in pans, waterproof clothing. A big one that people talk about are firefighting foams. But then there's a lot of other products out there that exist that have PFAS. The food wrappers, fast food. We were just having a conversation internally last week about how plastic straws transition to more biodegradable materials, paper source, things like that. But then there's a liner inside of them that also potentially has PFAS. Cable, wiring, building and construction, paper products, a lot of PFAS, unfortunately, in the semiconductor industry. So PFAS are still used in a wide range of both consumer products and industrial applications. And although PFOA and PFAS are no longer manufactured in the US, they are still being produced internationally and can be imported into the US in consumer goods, like carpet, leather, apparel, textiles, etc. One thing I want to touch on a little bit more in detail is AFFF. So in 1970, the Air Force began using a legacy formula of AFFF, which contained PFAS and PFOA, specifically engineered to extinguish petroleum fires. Again, commonly associated with burning aircrafts. And AFFF is the most efficient extinguishing method for petroleum-based fires, and it's widely used across the firefighting industry, to include all Federal Aviation Administration certified commercial airports, with the goal, again, to protect people and property. And the Air Force replaced legacy AFFF in all emergency response vehicles and stockpiles with an alternative formula in 2018. So it's really great to see that Arizona is also jumping on that. In the video, I know we touched about, taking back all the AFFF and swapping that out with PFAS-free AFFF. I wanted to show this slide about PFAS on a timeline. This is really interesting because, again, like I mentioned in the last slide, PFAS has been around since the 30s, right? That's when the chemistry was discovered. And in the 50s, many products were commonly used by consumers and industries. The two major production processes, included electrochemical fluorination and fluorotelomerization. So those were used to manufacture PFAS substances that contained perfluoroalkyl chains. And the awareness of the presence of PFAS, or perfluoroalkyl acids, can be attributed to occupational studies in the 1970s that found detections of some PFAS in the blood of exposed workers. Also, further studies in the 1990s that reported detections in the blood of the general population. In recent years, the presence of several long-chain PFAS, so those perfluoroalkyl acids, like PFOA, PFAS, PFNA, and PFHXS, those have been measured in lower parts per billion ranges in the blood serum of almost all residents of the US and other industrialized nations. So concentrations of some PFAS, especially PFOS, in human blood, it's really important to note, have decreased since the early 2000s, which coincides around the same time of the voluntary phase out of perfluoral octanol chemistries by a major US manufacturer. And although some PFAS have been manufactured since the 1950s, PFAS were not widely documented in the environment samples until the early 2000s, as PFAS testing was not widely available until that time. So since the early 2000s, analytical methods have been and continue to be developed with lower detection limits that commensurate with levels of potential human health effects. Due to the concern about the potential health and environmental impacts, there have been a reduction in the manufacture and use of certain long-chain PFAS. Long-chain PFAS include PFCAs with 8 or more fully fluorinated carbons, for example, PFOA, and PFSAs with 6 or more fully fluorinated carbons, like PFHXS and PFOS. This also includes their salts and precursor compounds capable of forming long-chain PFAS. I want to get a little visual representation here. Again, there's a lot of sources for PFAS, right? And there's a lot of ways that it can wind up in our drinking water, right? And so some of those major ones, are manufacturing emissions, which contain PFAS. The release mechanisms at primary and secondary manufacturing facilities not just include air, right, but also water and soil emissions. The spills and disposal of manufacturing wastes and wastewater that have potential impacts to the air, the soil, surface water, storm water, and even groundwater. And it's important to note that they're not only present at the release areas but potentially across the surrounding area as well. Again, all those consumer products that we talked about on the previous slide, those wind up in landfills. And right now, there's no regulation to say that those products, those compounds have to be put elsewhere. So in general landfills, there's the potential for it to get into our groundwater, find its way into our drinking water. Again, wastewater facilities and what's coming out of there. And of course, land applications of biosolids. It's really interesting to think is that in commercial agriculture, there is the potential for them to use biosolids, right, for other aspects of it, for other nutrients that can be present in biosolids. But those things can, again, go into the plants, they can go into the food, they can go into the water and work their way into our drinking water, unfortunately. So I know that a lot of what I've been talking about sounds a little scary, especially with what gets reported in the news. And there's a lot of quotes out there circulating about PFAS, but this is one that I really think is worth sharing. There's no acute threat, meaning there's no risk of going home and drinking the water out of your faucet. Even if your water system flags positive on this set of results right now, there is no risk to your immediate health by doing that. It's a cumulative impact over time. We do know certain health issues arise from decades of drinking this water. So again, the key takeaways from the quote is it's not necessarily acute and it's cumulative impact. And I think our video that hopefully, folks who were on the webinar earlier this morning got to hear that in our YouTube video. So I want to switch over and talk about history of PFAS in Arizona. And to go into that, I think it's important we kind of touch on, not just what are we doing here at ADEQ at the state level, but take a zoom out and kind of focus again on EPA and UCMR. And the UCMR program was established by the EPA in 1996 to monitor drinking water for contaminants that are not yet regulated under SDWA. And UCMR stands for Unregulated Contaminant Monitoring Rule. a public water system serving more than 10,000 people to test various unregulated contaminants every 5 years, and smaller systems may also be required to participate. UCMR helps the EPA determine if contaminants are present in public water systems at levels of public health concern and if they should be regulated in the future. The 1996 amendments to the Safe Drinking Water Act, SDWA, require that once every 5 years, the EPA issues a new list of no more than 30 unregulated contaminants to be monitored by the public water systems. The UCMR provides EPA and other interested parties with scientifically valid data on the occurrence of contaminants in drinking water. These data serve as a primary source of occurrence and exposure information that the agency uses to develop regulatory decisions. So I'm not going to go into details on all of the UCMRs, but a quick overview. The first UCMR dealt with 12 contaminants focused on perchlorate and MTBE. The second one had 25 contaminants, insecticides, herbicides, flame retardants. UCMR 3 had 30 contaminants, VOCs, SOCs, some metals, and that did include 6 PFAS compounds and 1,4-dioxane. That's when we began to identify that PFAS was here in Arizona. UCMR 4 was again 30 contaminants, cyanotoxins, brominated HAAs, pesticides, and then the last one, which we're currently in right now, is UCMR 5, which is focused on PFAS compounds and lithium. So I want to go into a little bit more detail on UCMR 3. PFAS was first tested during UCMR 3, which was between January of 2013 and December of 2015. It was tested public water systems, again, serving more than 10,000 people. And the results that came out of UCMR 3 from Arizona tested 82 out of 1,500 public water systems here in the state. We had 6 detections from those 82 public water systems. Now, again, what's really interesting is the participants had to be more than 10,000, serving more than 10,000 people. So out of those 6 detections, that accounted for 85% of our population, roughly 5.8 million people. And from those 82 systems tested, approximately 1,100 samples were taken. And those samples were either taken at wells or EPDSs. So 6 systems, again, had detections of PFAS compounds such as PFOA, PFAS, PFNA, PFHXS, PFHPA, and PFBS. I also want to go touch on UCMR 5 a little bit. So again, we're currently underway with the 5th round of UCMR testing. And UCMR 5 started in January of 2023 and ends December of 2025. It requires that all public water systems serving more than 3,300 people to participate in this sampling event. In Arizona, that includes 150 public water systems of, again, our total of roughly 1,500 public water systems. So again, 150 may not seem like a large sampling size. However, the 150 public water systems that are participating represent 6.7 million people being served drinking water here in the state. So that accounts for, I believe it's approximately 93% of the population. This time around, compared to UCMR 3, UCMR 5 is going to be testing and looking at 29 different PFAS compounds. The first set of data has already been released, which represents approximately 7% of the total results expected to be received until the completion of data reporting in 2026. The next round of data, the EPA plans to release another set in the next week or two, actually. So that's kind of in summary what's going on, EPA, UCMR 5. I also want to touch on this slide while we're here a little bit about what ADEQ has done since learning about PFAS being detected at UCMR 3. So again, in 2018, we prompted our own sampling project based on the data that we got from UCMR3. The sampling took place from January through April in 2018. This time around, we had 68 public water systems that were sampled with a total of 109 samples. So ADEQ, in order to come up with 68 public water systems being tested, we developed GIS maps which showed facilities that currently or historically may have used PFOA and PFAS. ADEQ also used standard industrial classification codes, so SIC, and conducted extensive research to identify these facilities. Based on the hydrological data, ADEQ then identified public water systems, drinking water well locations within a 2-mile radius of such facilities. Non-regulated water systems were not including in this screening since that was outside of the scope of the project at the time. So I want to share some of the findings from that. We had 12 new detections coming out of that 2018 sampling project at public water systems. This sampling event, however, only sampled for PFOA and PFAS and did not include any other PFAS compounds. That decision was made to only sample for those 2 compounds since they were the only compounds at the time that had health advisory levels. It's also important to note that the systems with PFAS hits, only 4 of them were above the then current combined PFOA and PFAS health advisory level of 70 parts per trillion. The remaining systems were all well below the 70 part per trillion health advisory level. So again, one thing I wanted to talk about in detail about UCMR5 and how it relates to what we're doing at state activities now is the EPA method comparisons. So they've mentioned that there are 2 approved methods that we can use and that they're planning to use for PFAS testing in UCMR5, and that is methods 537.1 and method 533. So what's interesting about 537.1 is it's a total of 18 PFAS compounds, as you can see in this chart on the left. And then there are 4 unique compounds from that one, and then method 533 on the left side compared to 537 on the right, where there are 25 PFAS compounds and 11 of them are unique. So in total, they're using, the EPA for UCMR5 are using both methods to test for a total of 29 compounds. 14 of those overlap, but really they're using 533 for the big portion, and then the unique ones are coming, the data is coming from 537.1. Again, also to note on UCMR5, they're not just looking at PFAS, they're also looking at lithium as well. So I also want to touch about just different nomenclature and when people talk about levels in Arizona over time, and again, nationwide as well. So health advisory levels, HALs, and maximum contamination level, MCLs. Those are some terms that I know Karen touched on in her presentation as well. They're used in the context of water quality and safety standards, particularly in the United States. These terms are used to assess and regulate the presence of contaminants in drinking water, but they serve different purposes and have distinct meanings. Health advisory levels is a non-enforceable guidance issued by the US EPA to provide information about the potential health risks associated with the exposure to specific contaminants in drinking water. HALs are typically set for contaminants that do not yet have legally enforceable standards, so MCLs, or for which there is still scientific uncertainty. HALs are intended to help water utilities, regulators, and the public understand the potential health risks and make informed decisions. And MCLs, it is a legally enforceable drinking water standard established by the EPA. It represents the maximum allowable concentration of a specific contaminant in public drinking water systems. When a contaminant exceeds its MCL in a water supply, regulatory action must be taken to address the issue, such as treatment, monitoring, or notification to the public. MCLs are established based on scientific research and are designed to protect public health. So in summary, the key difference between an HAL and MCL is that HALs is a non-enforceable guideline that provides information on potential health risks, while MCLs is a legally enforceable standard that dictates the maximum allowable concentration of contaminants in drinking water to ensure public health and safety. Overall, the big takeaway, besides understanding the differences between the two, is that the levels of PFAS continually decrease year after year. It's really been made clear by the EPA that PFAS does not belong in our drinking water. So I want to make sure we touch on this as we went from, for example, PFOA from 400 parts per trillion back in 2009 all the way to 4 parts per trillion with where we are today with the proposed MCLs from March of earlier this year. So let's go into our actual sampling project. So this has really been an incredible project since we kicked it off. We made the first announcement about this project back in December 16th of 2022. So when we put out a press release talking about how we're going to use $3 million from the BIL, the Bipartisan Infrastructure Law, which allows the ADQ to focus this effort on community water systems and non-transient, non-community water systems to do this huge sampling effort that we have been undertaking. So I wanted to share this photo of what it looks like when we're sampling out in the field as well. So approximately 765 public water systems are participating in our sampling event. From those 765 public water systems, there's going to be more than 2,000 samples taken throughout the project. And again, all of these samples are only going to be taken at the point of compliance, which is the EPDS. The main objective of our project is to conduct a statewide screening or sampling of all applicable public water systems for PFAS in order to identify and quantify the extent of PFAS contamination before the end of March 2024, which includes 2 samples taken per site with at least 90 days after the first sample has been taken. So some of the scope details we're talking about, again, it's about developing a comprehensive list of all the public water systems to be sampled and analyzed, collect the water samples, conduct laboratory analysis to determine the presence and level of PFAS contamination, evaluate the results of the laboratory analysis and develop a comprehensive database of PFAS contamination levels for all the samples sourced, and then take all that data and feed it into our ADEQ PFAS interactive map. So if any of you guys have not gone out to the ADEQ website, that's where you can find that, and I'll touch on that later and provide a link to that. And lastly, we're going to supply all the lab reports, all that raw data, and communicate those results to the public water system owners. It is important to note that there are a couple exclusions in this project. So again, to be good stewards of the funds and making sure we get that $3 million to last us as best as possible, we're not sampling some of the sites from UCMR 5. We're not able to use the funds for federal public water systems or state systems. We're not going to be testing any consecutive connections. And again, because transient non-community systems won't be regulated by the NPDWR, those systems are also not within the scope of this project. I also wanted to share some of the logistical challenges of this project. When I talk to folks about this project, they're like, oh, wow, this sounds great. You get to go out and just sample, right? It's pretty straightforward, easy. However, it is a bit more challenging than a lot of folks think. And so I wanted to touch on some examples of that. So when we're talking about coordination with multiple stakeholders, the project involves coordinating with public water system owners, admins, operators. We work with multiple laboratories, a lot of internal communications, And all those stakeholders can pose challenges in terms of communication, data sharing, collaboration. When we talk about the sampling logistics, so even just, again, getting on site to take those samples, again, we have to obtain permission to access private property. We have to, again, do more coordination with contacts and ensure proper handling and storage of the samples that we take. When it comes to the laboratory analysis, PFAS testing is complex and time consuming. It requires specialized equipment and expertise. And the capacity of the laboratories to handle a high volume of samples in a timely manner, it's also a challenge. So we'll touch a little bit more on that in a little bit. Data management, again, the project involves collecting and managing huge amounts of data. So again, the laboratory analysis results, GIS data, there are challenges involved with data quality control, data integration, and again, sharing. Resource allocation. So as you can imagine, there's a lot of personnel, a lot of equipment, a lot of funding. So challenges related to budgeting, staffing, resource allocation. And then lastly, one of the big challenges is public outreach. So we've recognized that the project can generate public concern and media attention. And we know that effective public outreach has been necessary to communicate the goals, methods, and results of the project to the public and to address any public concerns. I really want to just give a big shout out to our communications team, Office of Environmental Excellence, OEE, and our community engagement team. Just really coming together to collaborate to make sure that we are promptly responding and helping the public once they get their results back has been crucial. So when we break down this project, we talked about 765 public water systems to be sampled. I wanted to go through an example of what it's like, talking about one of those single public water systems. So this is the overall flow on a per public water system basis. The first thing that we have to do is do some preliminary communications, establish contact, get buy-in. Then we're going to do the actual on-site sampling. Once we submit those samples to a lab, we get that data then goes back to us. We're going to receive it, review it, QC the analytical lab results. And then finally, we're going to follow up communications with public water system owners and any other responsible point of contacts. So when we talk about the initial communications with public water systems, we do that with owners. Sometimes the owners are having us work through operators, third-party companies, or we're reaching out directly to admin folks. And we have to discuss the background of the project. Sometimes we're even discussing what is PFAS, right? We didn't have that YouTube video that we showed at the beginning of the webinar today when we first started this project. So we really had to do quite a bit of education up front as well. So we again focused our communications on end user health and safety, the fact that the testing for this project is free, which otherwise could cost about $775 per sample. And again, the potential to receive support faster than if you don't test at all and you're waiting until the rule goes into effect. And then lastly, we always talk about is making sure they understand we need to get a right of entry form signed, right? And then once we get through our preliminary communications, folks are on board with participating in the free sampling, then we talk about scheduling communications where we try to get our team or our contractors that we're working with on site to do the sampling that really works with their schedule. So we try to be as flexible as we can, but again, we're trying to get this sampling project completed as fast as possible. The next step is actually going out and doing the field sampling. So what's been great is the laboratories we've been working with are giving out, a sample kit for each method. So you can see in the picture in the bottom left here, we've got 4 bottles pertaining to 4 bottles for each method. And again, the methods 533 and 537.1. I also shared an image on the bottom right side of what a typical chain of custody form looks like that we have to fill out for every single sample that we take. And one of the cool things that we started with this project is we started using a program or an app called Survey 123. So instead of going out into the field with, the typical clipboard and, a pen that doesn't work or a pencil that also you shouldn't be using, this is great because we can use iPads, we can use cell phones, jump into an app, fill out fields as if it's like, an online survey program, and at the same time use that app to generate in real time GPS coordinates. So this has been wonderful for us to update our records for locations, and again to learn as we get data back from the lab about PFAS. The other thing that's really crucial with PFAS, if you guys haven't heard, is to again always adhere to the SOPs, standard training, but really the checklists. When it comes to PFAS, cross-contamination or environmental contamination, since we're measuring at parts per trillion, can be a higher risk. And I want to go into, before I go into those lists, those checklists, I just wanted to show again, what we're doing is really consistent to UCMR 5. We're using methods 533, we're using method 537.1 to get a total of the 29 PFAS compounds. And we do have the ability to work with multiple labs, but not all the labs have PFAS testing available. So right now, it's been really great to have options and work with some really great labs on all the samples that we're sending them, because it is a lot and it is a challenge to keep up. So when I was talking earlier about the checklists, every single time one of our samplers or contract samplers have to go out in the field, they have to adhere to all of these bullets. I'm not going to go through them one by one, but it's just important to note that the Ziploc bags, the blue ice, and even again the clothing that we wear has to be taken into account before we go into sampling. Because again, if we get a false positive of PFAS, we have to go back out there, spend more money, and resample again to make sure that again people have safe drinking water, right? Same thing before. There's even more things. People have to be cognizant of what they're putting on their faces, what they're putting on their bodies, or what they did before they even left their house before sampling for PFAS. And again, some other things. So every time this is built into our app, we are checking off these things, signing off on it for QC purposes to make sure we're always maintaining consistency and following our standard operating procedures. Lastly, it's all about communication, right? And when we get those results back from the lab and we review them, we want to share them with our public water system point of contacts. So it gets broken down into positive detections and no detections. When there's no detections, it's pretty straightforward. Folks are going to get a call and an email with their raw data set files, both in Excel and PDF formats. When we have positive detections to deal with, we always try to do a phone call first with them so we can talk through the results, especially for folks who aren't aware of PFAS. They're going to get their email with the raw data values. We provide public notice templates, a link to the PFAS introductory YouTube video that we also showed earlier today. We talk about next step recommendations, provide handouts for WIFA for contact information. We also provide an ADHS fact sheet, our own PFAS 101 sheet, and an EPA PFAS fact sheet. So quite a few resources. Again, all those are accessible using this QR code on the screen. So you can just pull out your phone, put the camera out, and you'll be able to access all of those things. And lastly, want to talk about moving forward. I know I'm running tight on time, so I'll try to go a little bit quick. This is the PFAS toolkit, also available on our website. Again, I know the date down here says December 22, but we should have an update coming out hopefully before the end of this year with some updated resources. Again, link to the PFAS toolkit. And again, when we do have detections of PFAS at systems, we do recommend actions. We assess the contamination. We talk about resampling their systems after 90 days. We always talk to them about how important it is to inform the public, their customers, and any users of their water, and talk about opportunities to limit exposure. This is an example of what the ADEQ PFAS interactive map looks like. As you can see, we have the blue is our first round and our yellow is our second round. So quite a bit of testing has been done to date. This gets updated fairly regularly. Again, we try to make sure we're not updating the PFAS interactive map until we have communicated the results to the public water systems, and that they get some time again to also communicate to their end users as well. And lastly, the last slide I want to talk about is some takeaways to date right now with the current project status. So we have sampled at least once in all 15 counties, counting for 84% of all public water systems that are within the project. The second round of testing is also started, and it's going concurrently with the first round, and we've gotten over 50 systems sampled to date. We've received lab results back from over 81% of the systems sampled. 76% of all the data we've gotten back of those public water systems, there have been no detection of any PFAS. And 13% of the public water systems that have PFAS detections below at least one proposed MCL, and 12% of the public water systems have PFAS detections above at least one proposed MCL. Karen also brought up earlier about Gen X. Absolutely, we have not detected any Gen X, but there have been the following detections by compound: 80 in PFOA, 57 PFAS, 136 PFBS, 81 of PFHXS, 6 in PFNA. What's important to note is some of these detections by compounds can overlap, meaning that some of these were detected at the same public water system. I know I've got 1 minute left, but I definitely wanted to open it up if there is a question. I appreciate it. So thank you.
Very nice. Thank you so much, Matthew. Very informative. We did have one question. You may have already touched on it. Well, you did already with the interactive map. But is this map itself, it's publicly available, or is this also going, or is there going to be a map specifically for certified operators at least?
Right now, the PFAS interactive map is made available to everybody. So it is a general resource. I would have to follow back up to see if they're planning on making an additional map specific for public water system owners or operators.
Okay, definitely. Thank you very much. Let's see, looks like from Regina, can we have the list of things to do, to not do when sampling?
Absolutely. Happy to share that with you. My email is attached. It's on the screen right now, so feel free to shoot me an email and I can get that to you.
All right, looks good. So without any further ado, we're going to move on to the next presentation. Thank you very much, Matthew, for your time. If anyone has any questions for Matthew, his email is up here, and we'll also have it linked at the end of the presentation as well. If you have any pressing questions that you couldn't get up in time right now, we'll have 15 minutes at the end for any further questions as well. Okay, thank you, Matthew. All right. Next, we're going to go ahead and move on to Yasmina, PFAS treatment mitigation. Yasmina, are you ready?
Yes, I am.
Perfect.
Let me share my screen. Okay. Can you just confirm if you see that? I know it's not full screen mode, but
Yep, I can see it
can
clearly.
you see? Okay. Then let me start that.
Looks good.
Just a second here to adjust something. Apologize, I have to move some screens here before I start.
No problem, Yasmina. And just so everyone knows, after Yasmina's presentation, we'll be taking a short 15-minute break at 10:30. So that's when our breaks will be.
still struggling here. Give me a minute, please.
Also, a few of you have asked for the link to the PFAS video that was shown earlier this morning. It was posted in the questions drop down twice, but if you still need that link, let us know. We'll repost it.
Okay, thank you, Ebony, and good morning, everyone. My name is Jasmina Markovski, and I'm Senior Engineer with Engineering Unit under Drinking Water section. I have been with ADQ for almost 3 years, so you might have communicated with me before or seen me in one of these workshops. In today's training, I will be talking about operating considerations specific for PFAS treatment projects. But before I start, I will read a disclaimer saying that the views expressed in this presentation are those of the individual authors and do not necessarily reflect the views and policies of the ADQ. As well, mention of trade names or commercial products does not constitute endorsement or recommendation for use. So over the next, I would say, 50 minutes that we have for this training, I will be talking about some basic PFAS properties that are helpful in understanding treatment background, then available technologies and how to select one, and what if you already have a treatment and you are wondering if you can adapt that for PFAS. And because after every application, we have to think about implications, I will summarize basic concerns of PFAS treatment related to simultaneous compliance. I will go shortly over permitting requirements and talk about where we are with accepting point of view and point of entry units as PFAS compliance option. I will finish with a local Arizona example of PFAS treatment that has been running for the last 2 years. And as a recap, I will summarize PFAS unique treatment operations. So let's get started with getting to know PFAS without going too much into chemistry details. So first interesting thing here is that PFAS is not one, but group of thousands of compounds. And table on the left is summarizing only proposed regulation for 6 listed PFAS compounds. Of those 6, 5 belong to group called perfluoroalkyl acids, with the exception of Genex that belongs to replacement compounds. So just looking at the name of these 5 compounds, you can know so much about their treatment potential. And this is how it works. So first letter is always P and means per, which tells you that alkyl C chain is fully saturated with fluorine. And this full saturation is what makes these substances so stable. Then second letter is always F and means fluoro. And third letter is very important because it varies and tells you actually the number of C atoms. This number of C atoms is counting those in tail, but also in head. So if you have C in head, it will be included here. And if you see O, for example, as a third letter in the name of PFAS compound, that would mean octa, which means that you have 8 C atoms in your compound. So this is very important because longer the chain is, lower the mobility and stronger the hydrophobicity of your PFAS compound is. So really, in a simple words, the longer this PFAS compound is, it's easier to remove that. So you really want to see as long as possible of these C atoms. That will help you with your treatment. And then last letter is functional group or head, And in case of these 5 compounds, it can be only S or A, where S stands for sulfonate and A stands for carboxylate. Both of them dissociate in water and eventually gives anion, which means that if you have water just at pH that is higher than 3, which is obviously going to be true for drinking water, functional group head of these 5 PFAS compounds is going to bear that negative charge, which is actually very helpful for us in terms of treatment, because that negative charge is what makes ion exchange useful as a treatment option, because that's that point of action. And below are examples of this naming convention applied to 5 perfluoroalkyl acids proposed for regulations. Let's see how this works on PFOS and PFOA as the most common PFAS compounds. So they both have tail that is non-polar and hates water, and they have a head that is polar and likes water. So knowing naming convention, you can immediately focus on third letter, and based on tail length, you can estimate breakthrough trends of your treatment. And this is because longer the tail is, stronger the hydrophobicity, and slower mobility, and also easier removal is. So just a quick example here. This is why PFOS is easier to remove than PFBS. So you see the difference in that third letter. So while one has 8 C atoms, the other one has 4. So it makes a big difference in the removal capability. And after you know about chain length, then you can check fourth letter and see what functional group you have. So there are only 2 options here. It's either S or A. And what you should remember is that S is easier to remove than A, and therefore breakthrough is again going to be different. So again, simple example here, you can compare PFOS and PFOA. The only difference is that fourth letter, and that's why that actually makes difference in the treatment capability. So PFOS is easier to remove than PFOA. So after you know the name, next thing to ask someone that you just met is where it's coming from. Well, we can take same approach for PFAS. Unfortunately, source identification of PFAS is very complex, but it is good to know as much as possible. So I know that Matthew talked about this as well, but here is how I summarize an important fact and what do we know so far. So we know that PFAS compounds are human-made, and that manufacturing started in 1940s. On the other side, they don't naturally occur in environment. So wherever you see PFAS, it is human-made. We are dealing with that because it's either released to the environment through that manufacturing process, or it is a result of use and disposal of PFAS containing products. PFAS is also persistent in the environment and resistant to typical environmental degradation processes, which basically means that environmental buffer cannot help here. Also, PFAS is highly mobile, so you can see that in soil, air, groundwater, basically everywhere. So even if you, let's say, if manufacturing is release that in the air, you should not be surprised if you eventually find that in groundwater, because it is highly mobile, so it is transferring easily through atmosphere, water, soil, sediment, and other phases. So to make things even more complicated, PFAS can have direct and indirect source. Again, this was mentioned before, but it's good to repeat. Direct source for PFOS and PFOA is discontinued because manufacturers stopped producing these, specifically PFOS, in 2002 and PFOA in period of 2006 and 2015. Indirect sources, however, still exist. So there can be few of these. First one that I have here and I want to talk about is precursors. And here you can see on this schematic, like a typical precursors for PFAS compounds are polyfluoroalkyl and polymer compounds. So they are not fully saturated and with the fluorine. That's why they are not so stable. And in the environment, or if it comes to metabolism of larger organisms, they can transform to these stable compounds or perfluoroalkyl compounds that are proposed to be regulated. Then beyond these precursors, we also have secondary manufacturing facilities, and we also have imported products that can contain these PFAS compounds. And as a result of discontinuation and replacement approach, we see trends where long chains PFAS are decreasing, but short chains are already showing an increasing trend. And this is because of this precursor impact, and also due to replacement activities, because replacements for traditional PFAS may not be less hazardous, and they are very difficult to be detected and removed from water. In other words, future is bringing short chains PFAS concerns, and that is something that should not be forgotten when analyzing your 29 compound screening results and planning accordingly for treatment that can accommodate both compounds and concentration variations. So after we met PFAS, we will go over technologies available to mitigate it. Here is a schematic that in a simple way makes difference between not effective, effective, and developing technologies. As not effective, we have conventional treatment. We have media filtration with media that is no carbon based. Then we have oxidation, advanced oxidation processes, biofiltration, and low pressure membranes. As effective, we have three best available technologies, where one is GAC, the other one is ion exchange, and the third one is high pressure membranes or reverse osmosis and nanofiltration. On the other side, we have developing technologies, and developing here means that technologies that show promise but have not been demonstrated yet enough. So here we, for example, have many destructive technologies. However, the real situation is a little bit different, and we cannot make a straight line between technologies like it's done in this simplified approach. And this is because technology is developing. It is moving process as well as testing is. So that's why here I have this diagram from 2018 that demonstrates that at least two variables should be analyzed when exploring treatment options. So these variables are on X, you have a range of practicality, and on Y, you have a stage of development. So according to them, activated carbon and ion exchange are best available technologies, which actually has not changed even now, like 5 years later, after 2018. And this is the main reason why ADQ recommends these 3 technologies, actually 2, and then eventually high pressure membranes, with no having intention to limit your selection. Side note here is that when I say activated carbon, it's primarily granular activated carbon, or GAC, and that is because powder activated carbon, or PAC, is considered really not effective for PFAS treatment, and that's due to high dose needed for, let's say, 90% removal of PFAS. So that's for powder activated carbon, and then for ion exchange, this is primarily one-time use ion exchange, because specific regeneration that you would have to have if you want to use it multiple times would shift practicality significantly to the left, and that ion exchange would not stay on this position as of now. So after all, treatment selection shall be driven by system specific, so that final product is reliable and easy to operate. Then it avoids and prevents foreseeable mistakes, and then eventually it's cost-effective approach that has a balance between both capital and long-term O&M costs. Simplified treatment selection criteria, at the very least, should be based on water quality parameters, O&M, operation and maintenance, and residual management, which all lead to 2 main recommendations. The first one is that selection should be driven by system specific, and participation of users, in this case operator, is crucial in a pre-design phase. So let's start with the water quality parameters as first selection criteria. Idea of water quality parameter screening should not be surprising for anyone, because you have to know what you have in your water in order to plan how to mitigate it. Questions that I thought that may arise for PFAS as a new contaminant are where to test, what to test, and how many tests to do. And basically, you have to know answers on these questions in order to provide crucial information for treatment selection, such as what PFAS compounds you have, in what concentration they are, and how does it vary over the time. The same things you have to know about competing and fouling compounds, but also other potential interferences that you have in your water. So let's focus now on PFAS only. There are 3 things that you have to know about PFAS in your water. First one, you have to know about speciation. And why is this important? So you have to make a difference between short chains and long chains. We saw in previous slides, it's a big difference when you have to remove short chains and long chains. So you have to know which one you have. Then you have to know what functional group your PFAS targeting compounds have. Again, this is going to be very significant for your treatment performance. And then eventually you are screening for 29 compounds. So they are all different speciations. So you have to know what do you have there. And really recommendation is to don't limit yourself on these 6 compounds proposed to be regulated, but to look for all of them. And then after you know speciation, you have to know what's the concentration for each of them. Concentration is important because it's driving factor for design, and it is really like regulating that breakthrough curve and controlling media lifetime. Eventually, you have to know if both speciation and concentration are having like some kind of variation, and this is especially significant and can happen over the seasons. So you really have to know what the variations are, because your treatment have to work in the worst case scenario as well. So it's really crucial here that when you are thinking about the variations, you have as many samples as possible to understand if you see some variation, and if yes, why and how, what is controlling them. So how to know all of this information? Well, it's ideal to start with existing data. So review your UCMR5 or ADQ sampling results to see what you have there before you start thinking what is addition that you have to sample for. Then when you are thinking about sampling, it's really going to depend on the type of source that you have and site specifics. And really minimum requirement for any type of consideration of treatment is UCMR5. And then thinking about sampling locations. So we know that both UCMR5 and ADQ sampling is done at EPDS, but when you are thinking about the treatment, you definitely have to go and check your source data. So EPDS itself is not enough for treatment considerations. And we'll talk more about this in next slides. But here, this table is showing a sampling frequency for UCMI5 monitoring that makes difference between surface and groundwater source. And reason for that is that different variability expectations that I talked about. So for surface water, you have 4 sampling in a year, while with groundwater, that's only 2. Please note that number of months apart is very important to catch impact of seasons, and lower the number of sample is, the most important this time step becomes. But there are other things in your water beyond PFAS that you should be analyzing, and that's all because potential negative impact. So we have 2 major groups of interferences. One is competing and the other one is fouling parameters. Competing is important because if you have few competing things in your water, they're all targeting to same adsorption sites on your media, and those sites are limited. So you have to know what is competing, what is the concentration, and other things when you are thinking about the treatment selection. This really can drive trade-off decisions. Fouling on the other side is important because it's clogging pores, and when it clogs those pores, it again indirectly is affecting treatment capacity, because when it's clogging those pores, it's really blocking those sites that you have, active sites that you have in those pores. And then not just that, it's also it's going to affect hydraulic of your system, and eventually it's going to increase O&M activities and costs. So fouling usually can require pre-treatment to avoid frequent backwashing. In general, I can say that competing parameters are more important than fouling because they cannot be removed with one pre-treatment vessel, like you can do for fouling. Instead, for competing, you usually have to have more complex treatment trains. And as with all other water quality parameters, you have to do tests in order to analyze impact and plan mitigation. To help with this effort, ADQ provided lists specifying water quality parameters that are of PFAS treatment interest. Please note that this list is minimum that should be tested and other parameters may be needed. And here is this recommended list. This recommended list includes PFAS speciation, cations, anions, and other water quality parameters that may have impact on PFAS treatment performance. I will not go into details here since this presentation is going to be available for your download. And switching now to operation and maintenance as a second selection criteria. So because this is wide and complex topic, I will be focusing only on few aspects. And the first one is selectivity and kinetics. When I say kinetics, I mean contact time between PFAS and media. So this table and a few others that you will see through this presentation are comparing specific treatment aspects between three best available technologies. For the sake of time and not high practicality or expected interest for membrane processes in Arizona, I will talk more about GAC and ion exchange. So in terms of selectivity, GAC is not very selective technology, and as such, it is less effective for shorter PFAS chains. While ion exchange is synthetic material with specifically designed functional groups, and that's why it is effective for a wide range of PFAS. This means that PFAS speciation may drive treatment selection. So specifically, if you have short chain PFAS, you may be forced to go with ion exchange because GAC will not be effective in removing those. So that was selectivity. And then we have kinetics. Kinetics of GAC and ion exchange is also very different. And due to specific empty bed contact time needed, footprint for equipment may be 5 times up or down, and space limitations may easily dictate treatment selection here. So that's why we often see ion exchange in small systems because simply they don't have enough space to accommodate GAC. Finally, it is important to recognize that GAC and ion exchange media beds are very different, and comparison should not be based on bed volume treated, but on water volume treated. Going further with operation, it is important to understand vessel configuration. There are a few options here. First, as shown on the left side of the slide, you have to think about number of treatment trains. And here you have one or multiple treatment trains option. Basically, your selection here will be a trade-off between cost and redundancy. So if you want to have alternating usage and enable continuous operation, multiple trains are highly recommended for that. Second, regardless of train numbers, you have options for parallel or lead leg operation. This decision is trade-off between complexity and efficiency. So a lead leg configuration is going to increase media efficiency, and it's also going to to help you to manage with chromatographic peaking, and altogether it is going to increase margin of safety. So in an ideal situation, you should have minimum 2 treatment trains, and each train should be in lead leg configuration. The last aspect of operation that I have here is pre-treatment. It is well known that for any type of contaminant, pre-treatment addition will maximize treatment capacity and reduce issues. This impact is, however, even more important here when dealing with PFAS, because we want to minimize or even eliminate need for backwashing, and that way prevent disturbance of mass transfer zone. So this means that even if your source has no specific issues, bag or cartridge filter is recommended ahead of ion exchange or GAC to minimize dirt and particulate accumulation on the top of media bed. Otherwise, for specific issues, you should select specific pre-treatment, and here I have like a few common examples. So if you have sanding problem, you will have some kind of sand separation as a pre-treatment. Then if you have iron and manganese, you will probably have filtration with oxidation. Then if you have free chlorine issue, like if you are chlorinating before for some specific reason, and that happens before you come to ion exchange treatment, you have to put some kind of dechlorination before ion exchange, because you have to prevent degradation of this polymer material. Again, if you have ion exchange and you have very hard water, softening would be recommended to go before ion exchange. And then if you have organics, but again, you have ion exchange, then you would probably think about like a technology conjunction here and put GAC in front of ion exchange. So GAC in this case would solve organic issue, but will also help with the PFAS treatment. And since we are done here with operation, I will go now on third selection aspect, which is residual management. So there are 5 categories of residue that you potentially have to deal with when running PFAS treatment. These categories are listed here, and first one is spent media. So that really means that you know, if you have GAC or ion exchange after they're fully saturated, you will call that spent media, and that spent media will contain PFAS. So that's one type of residue. The other one is concentrate reject water stream, and you will have this if you have reverse osmosis or nanofiltration. I'm sorry, here is a typo. So instead of ND, it should be NF. But both of these membrane processes are going to have this reject stream, and it's going to contain concentrated PFAS. Then if you are having granular media, you have to think about that initial flush water. So if you get a media that was not pre-rinsed by the vendor, you install your media and then you have to rinse that on site. So if you put ion exchange, that's in that rinse water, you may expect to see VOCs, while with GAC in the rinse water, you have to check for arsenic. And anyhow, you have to have management option for this wastewater. Then beyond this initial flush water, you may have backflush water. So that means during the operation, if you have to backwash your media, you will accumulate that backwash water like a waste stream, and you should not expect to see here PFAS, because just doing backwashing will not be strong enough to do desorption. So what is absorbed on your media, PFAS will stay there, but that backwash water will have some fine particles inside. And then if you have a pre-filter, and you will probably will, again, you have to know what you are doing with that flush water from your filter. But again, here we don't expect to see PFAS because pre-filters, unless they're GAC or ion exchange, but I mean, ion exchange will not anyhow be pre-filtered, because they're not selective for PFAS. You should not expect to see PFAS in that water. So you will notice here that color-coded are residual categories that will contain PFAS, and that is what makes difference here in regards to other projects that deal with, let's say, arsenic or nitrate, for example. So difference is that there is a pending proposal for PFAS waste hazardous designation. I listed here timeline for this proposal, and information that we have at the moment is that February 2024 is estimated time for final rule. Nevertheless, even before official regulation, for the sake of generator liability, we recommend that facilities plan for this rule. And this table is comparing residual management options depending on treatment technology. Media reactivation is possible only for GAC. If not reactivated, media can be disposed on landfill or incinerated, where all three options really requires special conditions and probably hazardous approach due to properties of PFAS. Residual water streams should not be concern for GAC and ion exchange because they will be generated only in case of media flushing that ideally should be minimized or avoided with help of pretreatment. Then on the other side, residual water stream is huge concern for reverse osmosis systems due to constant generation, high volume, and potential hazardous requirements. So if you focus only on spent media for PFAS treatment, your facility will have to know what quantity you are generating. You will have to know logistic for this management, and you will have to know how much is this going to cost. We already spoke about two existing options for residual management, and those are landfilling and thermal destruction, where we have reactivation and incineration options. Unfortunately, there are issues associated with each of them. So for landfilling, there is a proposed hazardous designation that I mentioned before, and we do not have hazardous waste facilities in Arizona. Then we have data gaps everywhere here. So destruction pathways are not fully understood, and we are missing field data, and we have to learn much more about emissions associated with this type of available thermal destructions. And then, so thinking more about thermal destructions, only specialized facilities can do it because this, what has to be done with the PFAS, requires very, very high temperature. So this temperature has to be higher than 1400 Celsius degrees. So only specific facilities can do that. We have a Calgon Carbon facility in Arizona, and it seems that they are available to do this. And we are going to work in the future with them to get more details. However, you should also know that this type of dealing with the waste might be limited in the future. And it really depends, you know, of data that are generated with the time. And this slide is demonstration of issues that some sites are already experiencing. Here specifically, we have Guam Island that has GAC treatment for PFAS, but not a solution for spent media. And as of now, spent media is sitting in bags and waiting for disposal resolution, while Guam is looking for treatment improvement in order to prolong GAC media lifetime and basically generate less GAC waste in the future. So look at this as lessons learned, and in line with previous slides, plan for these types of issues. So we are done now with general treatment selection guidance, and now focusing more on some specific situations that you may have with your system. So what if you already have GAC ion exchange or reverse osmosis installed for some other contaminant, but you discover that you also have PFAS issue? So these are 3 questions that I could think of that may help you to plan your next step. So first one is this treatment already incidentally happening? The other one is, what is PFAS concentration on the source? So you probably got detection at EPDS, but you have to go back and see what is actually happening at the source, and is this treatment that you are having is removing some of that PFAS. And then eventually, if this is happening, is there any operation change needed? What should you do next? So to answer these questions, there are 3 important variables to think of. You can also call them trade-offs, but you have to know that removing multiple contaminants is shortening media lifetime for PFAS. Also, PFAS is in line with this proposed regulation, is probably going to drive residual management options. And eventually, you will probably have to think about technology conjunction. So I have more details here about that, but let's analyze this in regards to technology. So we have GAC as the most practiced technology in United States. Ion exchange, something less, and finally reverse osmosis that is rare in non-coastal states such as Arizona. So GAC is more common for large systems with surface water source, where its goal is really TOC reduction, while anion resin can be seen in small systems on groundwater that have issues such as nitrate, fluoride, or arsenic usually. So in regards to PFAS, it can be expected that large systems can still use GAC if they have to remove a long chain PFAS compounds. However, due to high TOC competing impact, it is likely that additional GAC vessels will be needed at the end of treatment train to address PFAS specifically. And similar is with ion exchange as well. So while small system footprint and short chains can dictate ion exchange application, PFAS will likely require additional ion exchange vessels because there will be competition as well. And regeneration cannot solve this because it is usually not recommended for PFAS, while it's crucial for ppm contaminants. So let's see the real data now to understand how significant this impact is. So this graph is showing how the different TOC concentrations affect breakthrough for different PFAS compounds. I put red arrow on PFAS just as an example. And you can see that basically any TOC is dramatically shortening GAC lifetime for PFOS. So if you have groundwater with less than 0.3 ppm TOC, you can do more than 150,000 bed volumes before reaching 10% breakthrough. And this is this data that you see as a square. However, even just increasing TOC concentration to 1.3 ppm it will result in bed volume drop to about 15 to 20,000, which is about 10 times reduction of media lifetime. So while it's inevitable that this impact will be extremely important if you have surface water, it is also warning that even small increase in TOC may significantly change your media performance. So this was about GAC. And this slide is showing the same, but just for ion exchange. So if you look at the graph on the left and compare media performance for TOC of 0.7 ppm, 1.2, and 2.2, you will see that media lifetime can go from about 200,000 bed volumes to, I would say, 50,000, or that means it's causing 4 times more media change outs. That was a graph for TOC, but another graph on the right is showing nitrate impact. So nitrate is important because same type of resin removes both PFAS and nitrate, and therefore they compete. So here we have data for nitrate, and you can see how breakthrough is shifting left when you are going from 0.5 over 93 to 186 ppm of nitrate. So this basically means that if you have nitrate about 2 times MCl, which is shown with middle line, your ion exchange lifetime will drop at least twice. So it's all these impacts are very significant, and someone may say, well, I will just regenerate more often and then solve this with ion exchange. Well, unfortunately, that is not an option because regeneration of resin with PFAS is different. So this would require organic solvents, and eventually management of PFAS-rich waste is going to be more complex. And now switching to implication or simultaneous compliance. There are at least 3 potential impacts that installation of PFAS treatment can cause. First, for corrosion control, installation of reverse osmosis will be extremely significant and will require some mitigation measures. Ion exchange will change anion ratio and cause pH drop, but luckily this impact seems not to be long-lasting, according to recent publications. On the other side, GAC will probably be beneficial for corrosion. Second thing that I have here is microorganism colonization that can happen with any granular media or membrane technology, and it must be managed, which is usually done by addition of post-disinfection. Third implication is chromatographic peaking, that is also called dumping, and it's generally associated with granular media technology. This phenomenon is significant for PFAS that will start to leak out as a result of co-contaminant push impact. And this might be a very new term for you. So I have here a visual explanation of what is called chromatographic peaking effect. So this effect is a result of 2 factors that drive adsorption. First, affinity, and then concentration gradient, where you should know that neither one favors PFAS. Someone recently asked me if this is similar to Boole effect, and I realized that that was a great comparison, and that's how I ended up with this schematic. So when this Boole thing happens, a big guy can be TOC or nitrate, which is in ppm concentration, and they start pushing out small guys or PFAS that is in PPT concentration. And as a result, you will see the concentration of PFAS in the effluent that exceeds concentration of PFAS in influent. And this can be very significant. So this jump can be even double. So you cannot prevent this to happen, but there are ways of mitigation. So to mitigate, you will need to have lead-like vessels, and you will have to have extensive non-compliance monitoring between vessels and at multiple sampling ports. So this way you will know when to expect this to happen, and your leg vessel will be ready to catch that. So I will now touch permitting process at a very high level. And it is important to note that this process is nothing different than what we have for any other treatment or contaminants. So this flow chart is showing a recommended cadence of activities needed to meet minimum design criteria. You're all familiar with ATC and AOC steps in ADQ permitting process. However, there are activities that you do before and in between ATC and AOC, and that's why we ended up with those 6 steps. So this means that you start with the analysis of water quality parameters, and then you go through design considerations. Then you do some testing, and then you are getting ready for your final design. And when that is done, you come for ATC. After ATC is approved, you can start construction, and you have that startup step, and eventually you come for AOC, and you have to get AOC to start serving PFAS treated water. So our goal here is that you come prepared for ATC or AOC so that you do not risk denial. So that's why all of these pre-steps. And in addition to these general type of training, such as this one today, we highly recommend scheduling a pre-application meeting with us, where we can basically answer all of your questions and determine if your specific project is ready for ATC or AOC submission. So ATC step should be straightforward if you completed all previous activities. For ATC for PFAS treatment, you will have to submit application, design report, construction plans, startup plan, process monitoring plan, and O&M is highly recommended to be submitted with ATC, but it can be postponed to AOC. These provided documents must be for final, not preliminary design, so that after approved, you can start construction. And then after construction is done, you can collect testing results in line with approved startup and process monitoring plans. Next one is AOC. So an AOC approval is final permitting step. And for that, you have to submit, again, application, as-built, tests, and O&M if you haven't done so with ATC. All these documents should provide information about design after construction. So if you have any changes, they have to be noted and they have to be justified. So be careful here, because in accordance to Arizona Administrative Code, all the changes that you plan to do after ATC is approved, you have to communicate them with ADQ and get approval for those changes before starting to do them. So if you don't do that, but you come for AOC and show us a bunch of changes, you are risking that this may not be accepted. That was about as-built. Then you have to provide tests such as chlorination, Bacti, and pressure results. And then you have to show PFAS in treated water to show that this system is working what is designed for. And then you may have to provide other results, because as I mentioned before, if you have GAC installed, it might be initially leaching arsenic, or ion exchange may be giving VOCs. So only after an AOC is approved, system can start serving treated water. So while everything before was about centralized treatment, I will now show where we are with point of use and point of entry, and what are the current compliance limitations. So I see very often that point of use solutions are recommended as an easy fix in order to avoid all centralized treatment requirements. Well, this is not very true with any contaminant, and especially not with PFAS, where you are basically targeting non-detect and you are hoping to achieve that with extremely small devices. So while approval process is similar to centralized treatment, acceptance of point of use and point of entry is heavily based on NSF certification testing, which actually is what allows that plug and play approach. So for PFAS specifically, point of use and point of entry devices shall not be considered a compliance options until NSF certification is aligned with the proposed MCL rule. Beyond this limitation that will be probably addressed in recent future, it is important to mention that this type of treatment should be limited to 25 connections due to cost-benefit analysis and decentralized O&M. And because we see many deficiencies with this type of treatment, even for other contaminants, it is highly recommended to always coordinate with ADQ before you start thinking about this, and especially before going and doing shopping or installation. And here are a few additional details about NSF certification. So what is actually preventing us to allow this for compliance option? So currently on the market, we mostly have units certified to 70 ppt of combined PFAS in the effluent. So I said 70, and we know that proposed rule is for 4, so there is a significant difference here. In 2022, NSF updated standards. However, they again rely on previous health advisories, and units certified against these target 20 ppt in effluent, and testing does not include GenX. So market is really in transition between those two phases, but anyhow, not even the standard version from 2022 is aligned with the proposed MCL. So we have to wait for all of this to settle down before we start accepting these units for compliance. Next, let me show you a few things about how to find these units. So there are only 2 testing agencies as of now that do test for PFAS in line with NSF certification. So those agencies are NSF International and Water Quality Association. For PFAS, it can be only 2 standards. So it can be either NSF 53 or NSF 58. So if unit is based on adsorption, it will be certified under 53, and if it's membrane, it will be under 58. And then very important thing here is to think about the claim. So devices can be 53 or 58 certified, but that does not necessarily have to be for PFOS or for PFOA or for any other PFAS compound. So you may have certification, but claim is what we are looking for. Claim is telling us what is this device like certifying against and what the results are. And to find all of this, you can access 2 databases, and I put the links on this slide. One is leading to NSF website, and the other one to Water Quality Association. And another common question that I get is Brita filters are certified for PFAS removal? And the answer is not. They are not certified and they do not claim to remove any PFAS. So we know that in Brita filters we have activated carbon. So theoretically it may remove some PFAS. However, they are not certified, so we don't know anything about that removal. Finally, to show that all requirements that we talked about can be met, I have here local Arizona example for PFAS treatment that got ATC approval in 2019 and AOC in 2021, which means that they're in operation for the last 2 years. So this site is treating for 2 million gallons a day. They have both PFOA and PFOS in their water, but they also have 1,4-D, and they have high sediment. So their treatment train consists of descenders and bag filtration before water comes to UV AOP step. And then after that, they have GAC in 2 treatment trains. Each treatment train has lead leg vessels, so total 4 vessels of GAC. And that GAC is treating for PFAS, but it also is quenching that peroxide residual from UV AOP step. Also, each vessel here has about 670 cubic foot of GAC. Another interesting thing to note here is that the proof design included 19 micron bag filters for sediment issue, but this was not sustainable for operation, and they did 2 adjustments so that they are now using 50 micron ones. So while accurate design is very important, it is realistic to expect that some minor changes will be needed over the time. Another very important aspect of design is media lifetime, and here we have for this specific system that they see breakthrough in lead vessels after 2 years. So I did a quick calculation here. So if they have 2 lead vessels and each one 670 cubic foot of GAC, and if we have for GAC, we have cost of $60 per cubic foot, it ends up that just to change media in those 2 lead vessels, they need more than $80,000. So this is very significant. And when they change that, they will put these vessels in the leg position, but the next replacement will come sooner because those that were a leg and now becoming lead, they are already in use. They are not fresh media. So next replacement is coming sooner than 2 years. And one more thing to note here is that supply chain for GAC is not great, and they will have to wait for minimum 6 months for this change. So this further amplifies importance of testing to provide accurate media lifetime, but also doing like bunch of non-compliance sampling so that you can plan for this ahead of time.
Yasmina, we're at time. We're at time, so if you want to have one more slide, we're.
Let me see. So I have basically 2 slides, and let me go shortly over them. So sorry. To recap everything from today's presentation, I summarized here PFAS unique treatment operations. First, let's talk about unique treatment elements. So for PFAS, you have to think about the pre-treatment, because that pre-treatment have to remove sediment or iron, manganese, whatever you have in that water, because you want to eliminate that need for backwashing. Then you have to think about to have a lead leg configuration, because it's highly recommended as the only way to better control and prolong media usage. Then another recommended thing is to have vessels for PFAS only treatment, because there are a bunch of trade-offs with co-contaminants that you may experience here. And then after the treatment, think about post-treatment disinfection, because you may have a biofilm growth in the media. So you have to address that as well. Also, don't forget that you potentially will have to satisfy higher pressure requirements if you are adding new equipment here. And this usually can be that you need to upgrade your well pump or add some booster pumps. Altogether, if you had a system with no treatment at all, you can plan that PFAS will require you to add minimum five treatment elements, and those are shown in this slide. Beyond treatment elements, PFAS will also bring some changes in process monitoring. So you will have to monitor for both lead and lag vessels, and this is because of that chromatographic peaking or damping potential specifically. Then you will have many sampling ports, and you should monitor all of them to understand mass transfer zone. Also, you will have to have additional monitoring for free chlorine, and this is due to added disinfection or to prevent media degradation. Then finally, media changeouts may have some specifics as well. So residual management can be very specific because of that hazardous proposed regulation. But anyhow, you have to know who is changing, how, when, and so on. New media logistics, you saw that supply chain for GAC is not that great, so you really have to know when is that coming to be changed, who is doing that, how long it will take for vendor to do it. Are they taking spent media when they are delivering new one, and so on. Also, think about initial rinsing of media can be done by vendors, so check if that's an option and how much does it cost, because if not, you will have to do that at site, and then you will have you may have to deal with the backwash water with arsenic or VOC. Then when you are filling those vessels, this is all porous media. If you don't have previous experience, it is important to think about minimizing air bubbles. And altogether, you know, specific things about equipment disinfection and sampling may come here into the place. And yeah, this concludes my presentation. We can go on questions if there is any time, or wait to the end. I really apologize. It took longer than I expected.
No worries, Yasmina. Your presentation was very informative, full of a lot of information, and we do have a few questions if we can get through those. We have three. Yasmina, from your experience, any correlation on the preference of functional group over the length of the tail and selectivity? For example, between PFBSs and PFOA, which one breaks through first?
So definitely, I mean, this all depends on speciation, but also of concentration. So what I saw is that shorter the chain, it's going to break through more easily. So if you are comparing something like PFBS versus PFOS, PFBS is going to do the breakthrough much quicker. But again, it really depends, because what your goal is, because with PFOS, your goal is to don't get that breakthrough of 4 or 80% of MCL that we usually require. With PFBS, it is under hazard index. So it really depends what your initial concentration is, what are the other things, and how you can adjust for that. So it's not a number that you are targeting there. but it's going to break through much quicker, and that's going to happen with both GAC and ion exchange, with that difference that ion exchange will be better if you have shorter chains, because it's going to manage that better than the GAC. But again, any type of treatment that we have available as of now prefers longer chains.
Thank you, Yasmina. We have one more or two more. What do you do with the spent media? I know this depends on usage and water quality, but when do we need to replace the media?
Well, you have to replace media when you reach breakthrough or 80% of breakthrough. I talked about options that we have available. I'm just going through slides now. Basically, with spent media, you have two options: either to go and do to dispose that on landfill, or to do thermal destruction. If your media is GAC, you can think about reactivation, but if you have ion exchange, there are two options: either to put on landfill or to do incineration. So we don't know if this landfill will require this to be hazardous landfill or not. That really depends on future regulation that we hope to see in February.
Perfect. Last question. Do we need to treat backwash water for PFAS?
There are no such information as of now. So what is known is that if you have adsorption, and that's what is happening with GAC and ion exchange, so you adsorb PFAS. When doing backwashing, we don't expect that PFAS is going to be detached, desorbed from that media and go back to your backwash water. But we really do not recommend doing backwashing for PFAS because you are disturbing that mass transfer zone. So even though you did that before, now you have to consider this in a very different way. You are in PPT level of concentration. So any kind of disturbance is going to be very significant for media removal capability. So it is better if you don't do backwashing at all. Try to think about the pre-treatment. I know that this facility that I showed example, Picture Rocks, they did backwashing, first one after 2 years of operation. So they struggle with changing this bag filters. That all has a cost, but they do understand that they have to put backwashing on minimum. So just think about the pre-treatment and try to avoid backwashing. But I don't think so that you will have to treat your backwash water. Again, it is always recommended to test what is there in order to know how to manage that.
All right, perfect. Thank you so much, Yasmina. That's gonna conclude questions for now. If you have any questions, Yasmina, could we see your last slide, please? Please feel free to contact Yasmina. Her information is here as well, and we'll also post it at the end of the webinar. Thank you very much, Yasmina. All right. And so now we're going to go ahead and have a quick 10-minute break, and then we're going to conclude this webinar with funding from ADQ and WIFA. All right, we'll see you in 10:55. All right, everyone, welcome back. Looks like we're moving on to ADEQ funding for PFAS mitigation. Sarah, are you ready?
Yes, I am.
Perfect. You're under ADEQ meets, right?
Yes.
Perfect. There you go.
Okay, super. You see my slide?
I'm looking. I don't see your presentation just yet.
Okay, let me work on that.
There we go.
It's up now? Okay. All right. Well, hello, everybody. My name is Sarah Conrad. I am with ADEQ, and I'm one of the technical assistance grants project managers that we've got on staff. And I'm really excited to be talking to you today about some funding that we have specific for PFAS mitigation and drinking water. So here's what we'll talk about just as an
Sarah,
overview. Yeah,
I'm so sorry to interrupt. It's showing your slides with the email in the background, so not the presentation.
not the presentation.
Mhm.
Okay, let me work on that.
No worries.
Show. Is that better?
Perfect. Please continue.
Okay, thank you. So here's the outline of what we will be talking about today. First, I'm going to tell you about two funding sources that we have specific for PFAS mitigation. I'm going to talk to you about how we're going to be using those funds, prioritizing how we'll use those funds, some strategies that we've got in mind for PFAS mitigation, how the process will go overall, and then where we are now and what the next steps are. If I've got a few minutes and I know we're running a little bit over on time, I've got a couple slides on some other ADEQ resources, so we might just play those two by ear. So our first source of funding to tell you about today is a state appropriation. It's $5 million, and it came through with the governor's budget. So that means that we got it July 1st of this year, and we have a year to finish it, to spend it. We're not locked into that June 30th deadline. It's not that the money's going to go away at that point, but that is definitely our goal to go through this $5 million within the next 7 months. It is specific to PFAS mitigation in drinking water, and we're going to be using some of it for hydrogeologic studies, but most of it we're going to be using for projects direct assistance to public water systems. And I'll tell you more about those details in coming slides. And then we also have a $42 million grant. This is a federal grant, and it is called the Emerging Contaminants in Small or Disadvantaged Communities Grant Program. And the name kind of says it all right there. It's for emerging contaminants. Here in Arizona, we're going to focus on PFAS as the emerging contaminant. The federal designation of a small water system is one that serves 10,000 people or less. And disadvantaged communities. Both Chelsea and I will be talking about the definition of disadvantaged communities, so we'll go into that in coming up slides. It does require Build America, Buy America, because it is a federal fund. I'll tell you a little bit about that, but for the most part, DEQ will be managing that concern. So I just want you to be aware of it. And we're going to be using almost all of this money as direct assistance to public water systems. And luckily, we've got 5 years to spend this $42 million. So between the two, the 5 million and the 42 million, we have $47 million. So talking about them as a lump sum, we're going to spend $1 million on some hydrogeologic studies. Talk about that on the next slide. We've got $1 million set aside for things like outreach, public education, training like we're doing today, and some reference materials. And then most of the money, the remaining 45 million, will be direct assistance to public water systems. And this sub-bullet here is really important, so I'm going to mention it a couple times as I go through today. This is a non-competitive program, so there's not going to be a grant application process. Instead, ADEQ has developed a prioritization system and will be selecting the systems most in need and working directly with them. I'll be talking about that in a lot of detail coming up. Excuse me. So first, that $1 million that we've budgeted for hydrogeologic studies, We have some contractors under contract, and they're going to be looking at the PFAS data that we already have. And they're going to be looking specifically in 3 areas of the state, Yavapai County, Gila County, and Santa Cruz County. Once they've sort of seen what data we've got out there, they're going to try and fill in some data gaps. This could include drilling some monitoring wells to see what PFAS contamination looks like at depth. And the ultimate goal is we want to provide the water providers with an idea of the PFAS in their environment. So they can think about things like, if I drill a deeper well, will I still encounter PFAS? It's still going to be at depth? What if I drill another well over here? Or is treatment the best option? So those are the sort of things that we want to get out of these hydrogeologic studies. And so most of the money and most of my talk is on this $45 million, and it is for small and disadvantaged systems, and it is non-competitive. So what we want to do is make sure we find the most appropriate solution to mitigate PFAS in drinking water. And we know that especially for small and disadvantaged systems, a treatment is not always the most appropriate solution. Sometimes we need to step back and look at non-treatment options. Be talking all about what we might be considering as we look at those non-treatment options. But most importantly, the system has to agree to participate. So they will be a partner through all of this as we are going through. But it should be very hands-off for this system. We're going to be contracting as DEQ directly with design engineers and construction contractors, and we're going to handle all the payments. So the system won't need to be collecting invoices and paying them and getting reimbursed. Everything will be done through DEQ. We'll just need the system to be involved, like I said, as agreeing to the selective alternative, some on-site meetings, making sure the contractor can get on site and do the work, but otherwise they shouldn't have to pay a dime for the capital project. So I want to spend some time going through the prioritization system that we've come up with. This pie chart shows you the different criteria that we looked at, and I'm going to go through each of these one by one, starting with PFAS level. That's our biggest piece of the pie here. And this is all data that Matthew was talking about earlier, the DEQ PFAS sampling effort that he's been leading up, and the UCMR5 data that we're getting from EPA. We prioritize this the highest because, of course, this has the greatest public health impact for PFAS. So we looked at 3 levels. Is this first round of data coming in 4 times above the maximum contaminant level or hazard index for this particular system? Is it coming in at that proposed MCL or hazard index, or at 75%? And we wanted to look at 75% of the proposed MCL because we do know there can be some seasonal variation in these PFAS levels. So we didn't want to rule anybody out with just one sample collected. We want to make sure that we're looking at more than just one piece of data. The next piece of the pie we'll talk about are the presence of other contaminants. And specifically these 6 here: nitrates, arsenic, fluoride, radionuclides, lead and copper, and disinfection byproducts. The reason we wanted to prioritize these is that if a system is struggling with other contaminants in their water, in their drinking water, we are able to assist with this funding. As long as the primary purpose of our project is PFAS, we can also assist with other contaminants while we're working with the system. So this is sort of killing 2 birds with 1 stone for us and for the water system. These next 3 pieces of the pie are all equally weighted. So the first is disadvantaged community. That means that the system basically is a low-income system. So we look at the state median household income, and we look at the area that the public water system serves. And if the area's median household income is 90% or less than the state's, then we're able to consider them a disadvantaged community, and we prioritize them for this project. There also are designated colonias. That's a federal designation. It's a rural community in the border area that lacks basic services. We can also consider those to be disadvantaged and prioritize them under this funding. The other thing we wanted to look at is technical, managerial, and financial capacity, excuse me. So we want to be sure that the systems that we are selecting to receive this funding are able to manage the system in the long term. Is this system sustainable, basically? Do they have staff at the right level of certification to manage it? Do they have funding in place, rates in place that they can maintain, for instance, a treatment system in the long term? So we wanted to be sure that those things were already pretty stable with the system. And finally, we wanted to be sure that we were helping systems that have not already received financial support from the state for PFAS. There's only a couple of systems out there that were deprioritized based on that. The last two pieces of the pie are just little slices. The population served, I mentioned before that we're looking at 10,000 or less or disadvantaged. So we wanted to prioritize the disadvantaged systems over the small systems, but systems did still receive points if they were a small system. The smaller the system, the more points they received. And then we prioritize communities' public water systems over the non-transient, non-community public water systems. So I've alluded to this a couple of times now, but we know that small and disadvantaged systems, treatment's not always the best option because we have to think long term. The media was going to need to be changed out within a couple of years. That takes some technical expertise, that takes funding to be able to maintain the system. And this pot of funding cannot pay for maintenance. It can only pay for the initial capital project. As Yasmina mentioned, there's some concerns about how we can dispose of the spent media because we expect it to be designated as hazardous waste. We also want to be sure that the system is as easy to operate as possible. And so that's why we want to prioritize non-treatment methods. So that could be consolidation, interconnection, or deeper well. And we're not immediately jumping to treatment as our first option for this project. Here is basically the flow of the project. Right now, we are just wrapping up the data collection phase. That's what Matthew was talking about earlier. And we are working on identifying our candidate systems. We're starting to have very initial conversations, making sure the system is interested, collecting more data to be sure that they are actually having a PFAS contamination issue. And once we have selected the systems and finalized that, then we will move ahead with design and construction of those mitigation projects. So this is the process. Once we've selected a system, this will happen with each system individually. So we'll select a system. We'll have a meeting with them, talk to them about what we're going to do, make sure they are interested. Then DEQ will be selecting a design engineer, and we're working off the Arizona Department of Administration's on-call list. So we have a short list of engineers that we can very simply contract with and give them an assignment, which would be to prepare a compliance options evaluation report. That report is then given to the public water system for review and make sure that they agree that the option that the engineer is suggesting is the preferred option for the system. So once everybody's in agreement, the design engineer goes ahead and begins and completes the design of whatever option was selected. DEQ handles the payments directly to the design engineer. And once the design is done, then we go to another list at the Arizona Department of Administration. It's called the Job Order Contract List, or JOC list. It's a list of construction contractors that we can easily contract with, and we'll put them to work constructing the option. Again, DEQ will pay those construction invoices directly. The system will go into startup. And the public water system is responsible, though, for ongoing operation and maintenance and testing costs. So that's a very important point to make. With this funding, we can pay for all of these things here, but not the ongoing costs. So we can pay for validation samples. We're doing that in the next couple of weeks, looking at the systems that we're going to start talking to and doing some more, gathering some more data, so we can make sure that the PFAS levels are a concern We're going to also be taking water quality parameter sampling. So as Yasmina was talking about, if there's other contaminants in the water or constituents in the water, we need to know what they are so the design engineers can do the best they can with selecting a treatment option. We can pay for that, the design engineer's report and the actual design. We can also pay for permitting fees, and we're going to be paying for project management costs through the Arizona Department of Administration's contracts. And then we'll pay for the capital projects, whether that's treatment, a new well, a deeper well, restructuring, interconnections, consolidation, a range of things. And as long as the 51% of the costs for the project are for PFAS or other emerging contaminants, we can also address other contaminants with this funding. I'm just checking on my time here. I'll go through this Build America, Buy America slide pretty quickly, but the federal funds do require Build America, Buy America. Basically that all the construction materials, iron and steel, were produced in the United States. We have a definition of project on there, but I think the easiest way to think about it is if something is permanently incorporated into the construction site, it needs to be made in America. Now, luckily, the documentation requirement is not too strenuous. It can be a simple one-page letter like you see here. It's on letterhead. It's signed by either the vendor or the manufacturer, but it does need to identify the project that they're working on, the products that are going into the project, where those products were manufactured, and then the sentence at the very end, it actually refers to American Iron and Steel, which is the precursor to Build America, Build America, Buy America. So this last sentence would need to refer to Build America, Buy America. But as you can see, it's a one-page letter for each of the products on your site. I think I will pass on these next two slides. I did hear Karen and also Yasmina talk about the ongoing compliance monitoring. The key points we wanted to make were that the monitoring we are currently doing can count as the initial monitoring results, but there will be ongoing monitoring requirements for PFAS that will be required going forward, and that does need to be paid for by the systems themselves. So where we are now, we have almost completed our sampling project and we're working on the prioritization of systems. And we're very much just beginning contacting the systems that are candidates. So we've not made any final decisions on systems, but we're talking to the candidates to see if it is a possibility. Once those have been finally selected, we will formally announce them. Just a couple of trainings that we've had on PFAS. The first one here was just last week. It was a very technical presentation intended for engineers, and Yasmina gave an extended version of the presentation she gave you earlier this morning, as well as somebody from EPA, Tom Speth, gave two presentations. We did record it, and it will be available on our YouTube channel very soon if you missed it. And then the next one is to please save the date for February 1st. We are collaborating with the Arizona Water Association's Water Treatment Committee and doing a PFAS vendor forum in Phoenix. It'll be an in-person all-day event. We'll have some case studies of systems that already have PFAS installed at their site. And we'll have some vendors available so that systems can talk one-on-one with potential vendors and try to understand some of the many products that are out there. All right. Ebony, we are back on time. Would you like me to go through these last two slides or do we have some questions?
We do have a few questions.
Okay.
You have time to go through these, it might answer a few.
Okay. So these are outside of the PFAS technical assistance that we're offering. This is our general drinking water technical assistance program. Linda Taunt is a great person to contact there. Her information is at the bottom of the slide. But basically, DEQ offers free technical assistance to small systems. and it is provided through contractors, much like the process I mentioned before, or in some cases DEQ staff. And these are the sort of things here. I'm not going to read the list, but you can see we can help with things like asset management plans and system evaluations, scoping studies, design, training, quite a list of things that we can help with through technical assistance. So please contact Linda if you see anything on this list that sounds like it might assist your system. And then we are also actively working on the lead service line inventory. I'm sure you've all heard of that already. It's an EPA amendment to the lead and copper rule requiring all systems, nearly all public water systems in the country, to create an inventory of their service lines by October 16th of next year, so just under a year. We have hired consulting firms to help small systems. So you'll be hearing from them in the near future if you qualified for that effort. And if you've got any questions, you can email the general email there at the bottom, lslinventory@azdeq.gov. And so there is my contact information if anybody has any follow-up questions.
Perfect. Thank you so much, Sarah, and getting through at such a good time. We do have a few questions for you. Where can we find the list of systems that were considered for sampling? If so, can you please direct them where they can be found on the ADQ site?
I would refer that question to Matthew if he is still online.
I am here. So I believe the question was the list of systems to be sampled. Is that correct?
Correct.
Okay. The best way to get to that information is to just reach out to me directly, either by phone or by my email, and I'm happy to look up on a per public water system number basis which systems are part of the program.
Okay, I'll post that in. Thank you very much, Matthew. Also, how do you get on the ADOA's on-call list?
That is a great question. The person at ADOA who manages that, her name is Krista. Oh gosh, her last name is like Kelvingen. I will find her email address and put it in this chat.
Right, perfect. And then how do you know if you are UCMR 5, your systems?
I think that's another question for Matthew.
Matthew question.
Yeah, so if you were if you're a part of UCMR 5, then EPA contacts will reach out to you directly to notify you, let you know. They'll let you know your sampling date, and they'll provide a huge kit. A box will show up with all the materials needed and instructions on how to sample. But again, if you're not sure if you are a part of UCMR 5 or not, you think you meet the criteria, feel free to reach out to me directly, again, either by phone or email, and I can help look that information up for you.
Okay. Thank you very much. That does conclude the questions for Sarah. Thank you very much, Matthew, for filling in as well. And we're going to go ahead and move on to WIFA funding. So, Chelsea, are you on the line?
Yes, I am.
Perfect.
Can everyone hear me?
I can hear you just fine. Thank you. I'm going to go ahead and pass the screen to you.
Perfect.
And if we have to adjust view, we can do so.
Okay, let me.
Okay, so that one is on your notes presentation.
Okay, then let's change to. How does that look?
Perfect. Please continue.
Okay. Well, sounds good. Then we will go forward with this and appreciate the opportunity to present and the opportunity to sub out last minute. This was going to be Lindsay Jones talking to you today. She had a family emergency, needed to stay home with the kiddo. So you get the poor man's Lindsay Jones today, but hopefully we still get to share the relevant information. And of course, I can pass questions along to Lindsay as well as you have them. So first of all, to introduce myself, my name is Chelsea McGuire. I am the Assistant Director for External Affairs here at WIFA. I've been with the organization since about March as we're ramping up for some of the new programming that we have coming down the pipeline, and I'll talk a little bit about that. But today we're really going to focus on our opportunities for PFAS resources and what we can look at and how our funding tools might be a good fit for where your systems are and what your systems are trying to accomplish. So I think most of you are familiar with WIFA, but just in case you're not, at its core, WIFA is a bank, and you know how that works, right? You know how financing works, you know how all of that happens, but we are a bank that is located through the state of Arizona. And so part of understanding who we are also includes understanding who we aren't. And so I always like to make it very clear that, you know, we are not a regulatory agency. We are just a financing arm. Our regulatory friends at the Department of Water Resources and the Department of Environmental Quality, they're the ones that talk about and set the bar for how responsibly we want to behave and what those standards are. WIFA is different in that we don't have that regulatory role, but we are here to help you meet that regulatory burden and to help your system comply with the quality standards that we need to have. And so how do we do that? What's the tool that we use to help? The tool is money. And so WIFA administers 5 funds. Each of these funds has a unique structure. Some are loans only, some are grants only, some are a combination of the two. Some we're still developing, but all of them are really meant to play a critical role in meeting Arizona's current and future water needs. I'm going to talk mostly about our state revolving funds, our clean and drinking water, SRFs, you'll hear me call them. We will touch briefly on some of the other ones at the end if there's time, but these two are really the bread and butter of WIFA. For quite some time now, about 30 years, this is what WIFA has been doing. We have been the administrators of the clean water and the drinking water SRFs. The difference between the two, the Clean Water SRF is funding for wastewater systems. So wastewater treatment plants, construction and upgrades, non-point source projects, upgrading failing decentralized water systems is really important and something that we're trying to encourage quite a bit through that, and also stormwater infrastructure. Eligible entities for the Clean Water SRF include public jurisdictions like cities, towns, special districts, county improvement districts, tribal entities. The Drinking Water SRF funds community water systems. So it's public, private, nonprofit. The projects under this fund usually include things like treatment and transmission, distribution, storage, and consolidation of systems. So the eligible entities for drinking water funds are publicly owned community water systems, and that can include cities, towns, tribal entities, and again, those special districts. And so we've been around for quite some time, which is why most of you or many of you know who we are. Over the last 30 years, we've been able to give out about $3 billion in loans on the ground in Arizona, and about $102 million of that has been in forgivable principal. And that's going to be where we spend a lot of our time today, because we always like free money more than we like cheap money. At least I certainly do. We've got about 211 borrowers throughout the counties, and have maintained a AAA credit rating through all three, not just those two, all 3 of the major rating agencies. So like I said, you know, we're a bank, and we understand that there are definitely options when it comes to how you secure financing for the projects that your community needs. Some of those options are more attractive than others, and so what does WIFA do to make sure that we are the most attractive option for you? The first thing we do is we try to make our loans cheap. Maybe affordable is the more appropriate term to use. But because we are federally subsidized, because we get money every year from the EPA, we can offer discounted interest rates. So depending on the project, your community, your eligibility, all of that, our borrowers can pay as little as 80% of the market interest rate at the time that your loan closes. So in today's market, that is pretty attractive. Maybe it wasn't quite as attractive when interest rates were super low, but as they continue to creep up, that's something that can offer a lot more affordability. We can also offer flexible loan repayment terms up to about 30 years, depending on the life of the project. And so that cost of the financing can be spread out on your ratepayers as well, and help that rate shock alleviate a little bit. Another way that we differ from other sources is that we offer technical assistance. And we do this free of charge. This is basically help for our borrowers to do things like planning and design for their projects, making sure that they're prepared to comply with some of the hoops that come with federal funding. We talked a little bit about American Iron and Steel. I think we've probably mentioned BABA a couple times. Those things can make it more difficult to borrow from government entities. And so we do have staff on hand that can offer those resources to you. Again, that's free of charge, and so that tries to make it so that that's not a barrier to you deciding to work with WIFA to fund the water projects that you need. Another option that we have in place are our design loans. And so these are pre-project support. It's not a construction loan, but it's a loan for the planning that leads up to construction. And so these are particularly helpful, I think, for small systems when you might not have engineers or hydrologists on staff. And so you know what your need is, but you need to develop the best plan to get you to a place to meet that need. So the way that this loan works is to help you pay for those kinds of professionals. And we offer these loans at a 1% interest rate. You pay interest-only payments for 3 years on whatever the size of the loan is. And then after those 3 years, our goal is to get you to be able to come back to WIFA for the rest of the loan to actually fund the construction. And so when you do, we can roll that into a longer-term construction loan, whether it's with us or whether it's with somebody else, so that you don't have that kind of big principal payment due at the end of that 3 years as well. So again, trying to help systems that don't necessarily have the resources to get to a point where they can do these projects effectively and affordably. Like I said, we want to focus today on what that free money option is, and especially on the emerging contaminant side of things. Cheap money is a great option, but we want to talk about forgivable principal, and that's become a much more recent tool in our tool belt. And it's one that we're really excited about because it does have such a big impact on these very expensive projects, but also especially in communities that can't find financing or don't really have the appetite or the ability to go into a lot of debt. So the way this works is that eligible borrowers who are borrowing to build eligible projects may have some of their principal forgiven by WIFA. If you borrowed $1 million, you only have to pay back $750,000 of that, or whatever that means. So some of that money you end up getting for free. I do want to make clear from the get-go that forgivable principal is never guaranteed in a WIFA loan. However, it's been made very clear by our board that they want to see us doing as much as we can to be generous with our forgivable principal options. And that's especially true for disadvantaged and priority communities, which we will walk through later. We've talked about it a little bit already in a couple of the other presentations. But let's walk through some of the options. And so this chart here is for the clean water SRF, so that's the wastewater projects ones. The first threshold to meet is whether you are in an eligible community. And so on the chart, those A or B, either one of those can help you establish as an eligible community. So you meet the disadvantaged criteria, or you establish user rates, will support the debt service once your household incomes are met. Once that happens, move over to the other side of the chart to determine how much forgivable principal are you actually eligible for. So if you meet that, if you meet one of those A or B, and your project resolves a non-point source pollution issue, you could receive up to 100% forgivable for $250,000 or less of a project. So essentially that's the cap, that $250,000 to get your entire project as a forgivable. So basically getting that as a grant. Moving down, a 60% forgivable threshold, again, is that A or B criteria, but also you're looking at population trends and some socioeconomic stats like unemployment rates. And so that's, again, going to help you establish that your community really needs that and that this is the right way to get that option on the table. And then 50% forgivable is just those eligible community criteria. So again, a lot of flexibility here and a lot of options for different systems to apply for and to meet the criteria to get a significant amount of that funding for free. Onto the drinking water SRF, it's a little bit less complicated, I think a little bit more straightforward, because the threshold here is again, whether you're a disadvantaged community, but then does your project address a public health threat? And so there's obviously a lot of options here in the PFAS arena to show that your project addresses a very significant public health threat. And so this is, again, a little more straightforward, and the amounts are very flexible as well. So you can just see there, it depends on the size of the loan. Again, that $250,000 is kind of the up to that. You can treat it almost like a grant where you're getting all of that principal forgiven. And then as you go down and the size of the project increases, the most that we can give is that bottom line there, that 1.2 million or so, plus 15% of the amount over 5 million up to 10 million. It sounds really complicated. It's actually a pretty straightforward formula, but that shows you there how you can get that financing to be an even lower cost as you go forward. We've talked again, we've already hit on this in some other presentations, but do just want to make clear what the disadvantaged communities definition means. And this is a definition that for the most part, the feds control, because we are again talking about EPA money, EPA standards, but WIFA does have a little bit of independence over that. And so in June of 2022, we realized that the EPA definition of disadvantaged community didn't work very well for Arizona, that we have some bigger communities. And so as you look at kind of what they look like and where the need actually is, we needed some more flexibility and we needed some additional criteria in that disadvantaged communities definition so that we could reach the people that we really needed to reach. And so this is the current designation policy. So you have either the community is a colonia, community receive 50 or more LFC points, or, and this is the part that we added, the community has an area MHI of 90% or less of the state MHI. And so that has really opened up a lot more possibilities for us on where this forgivable principle can happen and where we can make that work. So a lot of, when I talk about all of this resources or all of the resources that are out there for forgivable principle, one of the reasons we have increased the use of that tool so significantly over the past few years is the bipartisan infrastructure law. And so many of you, most of you are familiar with that, but one of the major goals of the BIL was to tackle forever chemicals. And so it was a PFAS focus. Arizona has a pretty unique set of water and wastewater challenges, and a lot of them are regional and environmental in nature. And so these can be really economically difficult to address. So we are trying as WIFA to use the funding from the BIL to address those challenges in kind of an innovative way, but especially in ways that assist the so many small and rural and disadvantaged communities that we have that are really dealing with these problems and trying to figure out the best way to do that. And so I've talked about, what the criteria is, but how much do we actually have available in forgivable? So I want to make it very clear what this chart says. This is the amount of available forgivable dollars. So this is the number of dollars that we have to give out for free, okay? This is not the cap of our loan portfolio by any stretch of the imagination. Our loans can be much larger than this. Our loans are much larger than this. But this just gives you an idea of kind of what resources we have as we're talking about these forgivable dollars and this free money. What's the extent that's out there? And so you can see significantly more in the drinking water side of things, and a ton of that is because of the bipartisan infrastructure law. So an emerging contaminant specifically, there's a $13 million pot, and then again on the clean water side, a $1.4 million pot specifically for emerging contaminant projects. So over the course of the BIL, so this is not just for the past fiscal year like that previous slide was, but over the whole course of the BIL, we anticipate funding of about $170 million for grants and loan forgiveness for Arizona communities, specifically to address PFAS and other emerging contaminants. So these funds will flow through the two revolving funds that we've talked about, but they'll also flow through the smaller disadvantaged communities emerging grant programs. We've talked about that. I had a great presentation on that, so I won't go into a ton of detail, but you do see there just how much resource is available to deal with some of these issues. WIF has already committed to Tucson and Marana over $150 million in SRF loan funds. Of that $150 million, about $20 million of those will be in loan forgiveness for PFAS treatment projects. We've also provided ADEQ with $3 million of our set-aside funds to assist small systems with sampling. So again, we heard about that a little already. We anticipate that as the results of those are released, plus the announcement of the proposed MCL, we're going to see a lot more systems that are interested in funding for PFAS projects. When you look at that proposed MCL and just how stringent it is and how we're trying to deal with that, we definitely anticipate an uptick in interest in the opportunities that WIFA has for those resources. So right now on our project priority list, we have 2 pending projects, one for Prescott Wells remediation for about $7 million and one for Marana water treatment disbursement for about $16 million. I also do want to note too that clean water SRF emerging contaminant funds are available for septic to sewer projects, those really critical decentralized projects. We do need to do testing of that septic water for EPA to approve the funding for that source. And so again, you know, we're doing that testing, trying to make sure we can get the resources on the ground for that. But we do, again, really want some more of those projects to apply. You see, that's the most limited pot that we have, but I think in projects like that, a little can really go a long way. So keep that in mind as you're looking at some of your potential projects as well. So how do you apply? What does that process look like? For cities and towns that are less than 150 people, all you need is a resolution from your governing body in order to authorize that debt. Greater than 150,000 people, typically you do need voter authorization to enter into that debt under our statutes, but we have an exception to that right now if you are using Infrastructure and Job Act funds. So keep that in mind right now, that if it's that IIJA money, you can even circumvent that voter requirement threshold. Tribal entities, we also just need a resolution from your governing body. And here's how it really works. So first you put a preliminary application in online to be on what we call our project priority list, or our PPL, you'll hear us call it. That you can kind of stay on the PPL for as long as you need to get all of the rest of the pieces in place. But that's a placeholder for us that lets us know you are interested in this. We are here as staff to work with you to get the ball rolling on that. Second part after that is that debt authorization. And so that's where you need to determine how you need to go into that debt authorization or how you need to obtain that authorization. Once you have that, that tells us that you are ready to roll. And so we will send you a PFA, or a project finance application, and that's a much more detailed application than the preliminary PPL. So that's going to be all of the legal and technical and managerial and financial capability, all of that goes into your PFA. Once we have the PFA completed and we've done our due diligence, the board will look, our WIFA board will look at that application. They'll go through that, they'll determine whether that is a loan that they want to enter into. Once they vote yes, then we will draft the loan documents, do all of the execution, and then that allows you to start on construction. That sounds like a really long process, and I won't lie and say that it's not a little bulky, but do know that if you already have debt authorization in place for your project, you can go from that preliminary application to project funding in as little as 3 months. We have made that happen before. We can make that happen. So just keep that in mind too, that we can move pretty expeditiously, especially if you already have that debt authorization in place. If I do have a couple more minutes, which it looks like I might, I'll just put in a quick plug for some of the other funds as well. These are not emerging contaminant or PFAS specific, but I think they are important parts of maybe the overall water portfolio and kind of what your systems are looking at. I'm just going to talk about 2 of them. The first is the Water Conservation Grant Fund. Hopefully many of you have heard about this. I know many of you have put in applications under this. Just like it sounds, it is money for the decreases or long-term sustainable reductions in water use. We have a pretty tight deadline on this. We have to obligate this funding by June of 2024. We actually have a little bit earlier expenditure deadline than that as well. It's closer to probably June 2026. It's something we are finalizing with the governor's office right now. But if you are interested in some free money with a 25% match requirement under this fund, applications are due the 30th of this month. And that will be the last round of applications that we have open under this grant fund. So if you have any questions about that, reach out to Lindsay, reach out to myself. We would love to see your systems putting in that application as soon as possible. And then the last one I'll mention very quickly is the Water Supply Development Revolving Fund. This is the least built out of any of the funds at WIFA, and so we are absolutely mentioning it to everybody who will listen to us, or captive audiences as the case may be, because I think there's a lot of applicability and a lot of potential for this fund, especially for smaller systems. So this is a fund, and the goal is to allow communities that don't have necessarily access to ready water supplies or the ability to acquire those water supplies to augment their supply through water supply development projects. This funding is not available for use within the CAP service area, so it has to be communities that are sort of outside of that urban center. So you'll often hear folks refer to this as our rural fund. And the way this is going to work is going to be very similar to our SRFs, and that it is a revolving fund, so there is a debt aspect to a lot of what will happen through this funding. But there's also a grant aspect. And so we can provide grants of up to $2 million and loans of up to $3 million for those water supply development projects. We're still working on all of the rules and what that's going to look like, but it is going to be very similar to what we've seen with clean and drinking water, and that will look at community criteria, prioritize disadvantaged communities, prioritize communities that don't have other options for this funding. And I think there's a lot of room to do creative projects as well, where you're doing some water supply, but there may be an emerging contaminant aspect of that because you're trying to move away from a supply that is too expensive to treat. I think there are lots of scenarios here where this could be a really, really helpful tool and helpful resource. So I say all that to say it's still in development. We have $190 million right away available for these grants and loans. So make sure that you're signed up for our email blast, that you're signed up for our lists, and that you have my contact information here on the last slide, because that'll help you make sure you're on top of any announcements we have, both on that fund and all of the 5 funds that we have. So that's everything I have to share today. Happy to answer questions if you have them, but appreciate the time to be able to talk more about where we might be able to help.
Awesome. Thank you very much, Chelsea. We do have a few questions here. It can also pertain to Sarah if she's still on the call. But from Leanne, do you have a rough budget number-wise for PFAS, PFOA testing for smaller non-transit, non-community water systems? Say less than 10,000, but probably more than 3.
I do not have a budget, but that is a good question that we can talk to, or I can talk to my projects team about. I think a lot of that is still in development right now as we look at the different things that are on our list and how we're putting those together. But let me get back to that and see if I can give you a more definite answer.
Perfect. Do you, Sarah, have a follow-up for this on the 8EQ side?
Yeah, so we used a $3 million pot of money for the testing that is being referred to there. I'm not sure if we used all of it or not. If Matthew's on the line, maybe he can speak to that. Or perhaps Karen.
I know that we've done sampling at the nonprofit, non-transient, non-community systems. So we are trying to prioritize those over, let's say, a for-profit business.
Mm-hmm.
Definitely. Looks like from Leanne, at the end, if you would like to contact Chelsea directly, as well as ADEQ, we can follow up with that question. So we have another one here from Joan. Does WIFA give loans to small water companies that are incorporated?
The answer to that is absolutely yes. We do. We can work with you to determine where and when and what that project needs to look like. Just let our team know.
Thank you. And yes, Chelsea's presentation is the same presentation that is attached to the ADEQ funding PFAS in your handouts. Cheryl, since we can only fit so many handouts for download, the ADEQ and WIFA funding presentation were attached and available in the handout section. Perfect. So we have a few more minutes for questions, but we do want to bring back up this post poll, but if there are any more, please put them in the question box. In the meantime, thank you very much, Chelsea, for your time.
Thank you.
So we're going to go ahead and bring back up the poll questions earlier. We had 2. Now that you've gone through this webinar, you've heard all of our presentations. We want to go ahead and make sure the information got across. So what is the PFOA proposed MCL? here. Perfect. We'll go ahead and give you guys a couple more seconds. And Karen, would you like to explain the answer? I believe this pertains to your presentation.
Sure. So the proposed MCL is 4 parts per trillion for PFOA and 4 parts per trillion for PFAS. And then, of course, let's not forget the health index for the 4 additional PFAS compounds.
Of course. Thank you very much. And you are all correct. This is actually better. We have 93% agreeing this time around versus the first time. We were at 71%. So we'll go ahead and move on to this next poll. Okay. When is EPA proposing to promulgate this standard? I'm going to get that word down. And Karen, I believe this also pertained to your presentation. Do you mind covering the answer for us?
Sure. So originally, the second answer is correct. Originally, EPA would like to finalize or promulgate the rule at the end of 2023, here in December. It is what we've been told likely going to be postponed by a couple of months, so they're projecting spring of 2024.
All right, perfect. Thank you very much. And this is also a great improvement considering only 31% of you originally thought the standard would come out in 2023, while most, 44%, answered 2024. So as Karen mentioned, it's now postponed, but it is likely postponed, but we should be seeing more information by December 2023.
And just to reiterate, the states have 3 years then to implement the rule from the time of promulgation.
Right, perfect. Thanks, Karen. Any follow-up questions for any of our presenters, from Karen to Matthew to Yasmina, Sarah, or Chelsea? Please put those in the questions box if you have any. We do have quite a few thank yous and appreciations to all the presenters today for the information they shared. There was an edit in presentation earlier. We'll go ahead and send out that edited presentation to everyone so they have the most up-to-date information available. Just make sure that you were registered for this exam. That's how we'll get your email contact. Excuse me, not exam. You're registered for this webinar. That's how we'll get your contact information. But it looks like that is the end of all the questions. Don't have anything else to follow up with here, so go ahead and share the screen. Meets, audience view. Did I take? Sarah, do you mind passing screen control to me? Can't seem to get it.
Yeah, I
Show.
don't see you listed as a
It should
link.
be other ADQ
There you
Meet.
go. Let's try
Oh,
that.
perfect. Okay. Thank you so much.
Mhm.
All right. Okay, sharing. Okay. All right. Are you able to see the end of the presentation well, Sarah?
Yes.
Okay, perfect. Thank you, Karen. Well, thank you everyone for attending. This wraps up our PFAS 101 workshop. I know originally this was supposed to be in person and virtually, but we had to cancel the in-person. So apologies for any inconveniences. If you'd like to contact any of the presenters you heard today, please see their emails here listed. Chelsea, your email's not listed, but I did put Lindsay's email. So if there's any questions directly for Chelsea or Lindsay, go ahead and send them there. Also, if you need any handouts or agendas, please contact me at the azopcert@azdq.gov. And please make sure you grab an agenda on the way out. If there are still any more questions, please feel free to post them in the questions box. 10 minutes here. How you get PDHs for this webinar, Anthony? By downloading the agenda in the PDH, or excuse me, in the handout section. If you don't have access to that handout section, please email me. My email is at the bottom, Ebony Roan, or you can email the AZOpsert at azdq.gov. Can get Chelsea's email.
I can type it in the chat if that helps.
Yeah, go ahead. I can add it to the screen too. We'll go ahead and remove. Let's see here. Okay. And for anyone who needed Chelsea's information, went ahead and updated that slide since she did present for us today. All right, we'll give you guys one more minute to go ahead and download any other presentations or add questions, and then we'll go ahead and end the webinar. Okay. All right, the webinar will be ending now. Thank you all very much for your time and attendance, and have a great afternoon.